All right, welcome back, ladies and gentlemen, after the break. So, I hope you have had some nice lunch. I could see some of us digging into nice sushis. I know even I was doing that, so I hope we had some yummy lunch there. So let's begin with the next set of presentation. Ladies and gentlemen, we have with us the Vice President of Product Management from Google, who leads groups focused on the software, network, and computing infrastructure, translation products, and internalization, localization of Google products. Could we have a huge round of applause for Anjali Joshi?
I don't see Matthew here, but a big thanks to Matthew for inviting me to be here, and I'm very honored to be speaking to you about some of the work that we are doing at Google. But before I start, what I want to do is just a quick follow-up from the previous discussion on diversity and women and how we can get more women to participate. And I am speaking now to the parents, and I'd say that please give your daughters the same opportunities that you give your sons. The reason I'm here today is my parents sent me to IIT as they did with my brother, and I couldn't have been successful in my career had they not given me the opportunity. So please do it, moms and dads. Okay, so my topic today is customer experience transformation through machine intelligence. And I'll start with some examples and some work we've done, and then I'll talk about how is this thing going. Okay, so what I'm going to talk about today is the impact of machine learning, and I'll start with some examples. What has made this impact possible today? And what's going on in India and how India can be really successful at this, and then what do we need to do in order to take the next steps. So the first thing I want to spend some time on is what I always say is solving for emerging markets is solving for the world. And why do I say that? Emerging markets are typically quite challenging. You have to work on phones which have lower spec, they have lower memory, they have lower processing power, and you need to make applications work really well on them. The second thing is poor connectivity. Of course, before Jio happened, India had poor connectivity, intermittent connectivity, and now, of course, the game has changed, but in many other parts of the world, connectivity is still an issue. And the third thing that we focus on is content. And we need to make sure that it's localized, it's relevant, and it actually works for the people to whom it is targeted. So all of these three things become quite a challenge as we build for these markets. The next thing is that new users online are very different from users that we encounter in developed parts of the world. First of all, they are lower income and literacy, which means that they want to get products that are much more affordable. There are literacy issues, in which case, they want to watch more video. We see a whole lot of watching of video because people, are struggling with reading text and so on these small screens, but video is extremely popular. Lots and lots of more women who are now coming online. They are using their phones and they're using it to, find their recipes, find opportunities, do lots of things. But again, video is very popular. And then with the Jio smartphone and other phones, we are seeing a lot more rural users. And often these users are monolingual and they are non-English speaking. So the content as well as the context has to be localized to them. So let's talk about one of these products that we built. How is this not switching? Okay, finally. Okay, so let's talk about the product that we built over the last 6 months and we announced in December. This is the Google Assistant for the JioPhone, the Jio Smart Feature Phone. And this was a very ambitious project for us because we wanted to build the assistant for a feature phone. This had never been done before. We had never done it before. But we wanted to make it happen because it's so important to have an assistant on the smart feature phone with the T9 keyboards. Even though you have great access to data, it's very difficult to type, it's very difficult to navigate and so on. So it was really important for us to have voice on these phones. we built this product together with the Jio team in less than 6 months. And the reason we could do this was because we were using a lot of our existing assistant technology. And all of that is, of course, as you know, powered by machine intelligence. So speech recognition, which has now moved to deep neural networks, and now it has very, very high recognition quality, was ported over to this system. Natural language understanding in English as well as Hindi. Personalized search and answers so that we could give people locally relevant content. And then, of course, our large infrastructure of query and intent matching, which we use over search. So this product was launched in December, and it's been received extremely well. And what I would say is that, you know, we didn't expect as high usage as we were getting because we thought that these users would have trouble with the technology, but it's been a huge success, a lot of voice queries and a lot of search queries, and of course, a lot of YouTube. Okay, so let's talk about how machine learning helps you in your other normal day-to-day activities. And many of you must use Google Photos. And if you ever tried to share a photo with somebody, it's like, it's really hard because you're swiping, you're browsing, which month was it, which place was it, let me see what I was near, and so on and so forth. But with machine learning, we built the search feature in Google Photos. And so if you want to find Maui Beach, or, you know, try it, or anything, any person, any place, then you can just type in the search bar and it will find you photos of whatever it is that you're searching for. And how this happens is really quite remarkable. I mean, we did a lot of image understanding, used neural networks to classify all of these photos and label them so that when people searched for these photos, they could find them. And each of your photos is labeled, so you can find photos of beaches, photos of cats, photos of all kinds of objects that you're looking for. And this is something that is a very nice feature, but people don't quite understand how much technology has gone behind it to make it happen. And this is an amazing application of machine learning. Okay. Another very interesting product that travelers often use is instantaneous translation. So this combines both vision as well as translation. So when people point their camera towards a sign, you can specify which language you'd like to see that translated to. In this case, exit gets translated into multiple languages. And this, again, a lot of the processing happens on the device, and it's all the more remarkable for that because a lot of machine intelligence and machine learning models have been ported on these phones. So these are some of the applications that are quite common and consumer applications, as you might have seen with Gmail and auto reply and many other applications of machine learning that are being now ported onto these phones, and we are now using them day to day without really thinking of how much technology is behind them. So I want to spend some time talking about the health applications of ML. It's partly, one thing is I'm super interested in how we can bring technology to enable access to healthcare where there aren't any doctors, in many of the rural areas in India. So this is a picture of a clinic in Delhi. It's called a Mohalla clinic, which is a clinic operated by a single doctor. The volume of patients that he sees typically in a day is about 300. So you can imagine the speed with which he has to do his diagnosis, keep his record, and so on. If you notice that on his desk is a tablet. And on a tablet, there's a software application that we had built where you can put in symptoms, and then using machine intelligence, it will surface the conditions that the patient may have based on the probability of it, and this depends on previous factors, the location, prevalence of disease in a particular area, and so on. One of the questions that I asked the doctor here is, what would you want if we were to apply bring you some technology? And the thing he said is that I get a lot of people with diabetes, and I cannot tell whether they have diabetes-induced retinopathy, so I have to send them to the local health clinic, which is often, for these people, far away. It's a long bus ride, and it's a lot of trouble and waiting in the hospital to have their retina imaged and to be diagnosed whether they have retinopathy or not. So he said that if you could give me a device which I could use where I can tell whether a person has retinopathy or possibly may have retinopathy, then I could save at least 50% of the folks trouble of going to the hospital and waiting and being tested and then be told that they don't have any retinopathy. So at Google, we spent a lot of time and through data that we acquired from the Sankara Eye Hospital as well as the Aravinda Foundation in India, have built these models which help in the detection of diabetic eye disease. And the accuracy of it is now close to what the experts can determine looking at these images. On the left side, there is a camera, which is a portable camera, which takes images of the fundus, and these images can then be sent to the cloud, and then you get a result which is whether the patient has diabetic retinopathy or not. There's a great deal of potential for applications like this, and if the camera on the left, which is a dedicated camera right now, could be ported onto smartphones, then can you imagine what the impact would be on rural healthcare in India, where through a smartphone people could take images which then could get sent to the cloud, diagnosed, and the doctor then would be able to tell whether the person has retinopathy or not. So several applications of these types of imaging have been built in at Google, including pathology and dermatology. And I see huge potential for these type of applications of machine learning for providing rural health care, where you can have a nurse take an image, send it over, and then get a diagnosis. Machine learning is being recognized as a technology that can be used to solve critical problems in many fields. And two startups in India, one called Niramai, which is doing thermal-based imaging using phones in rural areas, and then doing analysis using deep neural networks on the imagery to determine whether the woman has breast cancer or not. And the second application, which is also very interesting, is again based on image processing, is crop quality assessment. And today they need people to look at one type of crop and another type of crop and determine the quality and the pricing and so on. And this company called Nebula takes images of the crops and then can tell and classify it based on the quality. So there's a lot of opportunity over here. I've shown you a couple of startups, but there's a lot more. There's a number of them in India who are now taking advantage of the machine learning technologies that are often open sourced and then using them to solve relevant problems in many verticals. So let's look back a little bit and see what's made this impact possible. I mean, this could have been done 10 years ago, but it hasn't. And it required the confluence of a number of things to come together before we could actually do this. So one is, of course, faster computing. And processing power has increased in a huge way over the last 10 years. And also, there are large numbers of data centers full of these processors in clouds that people can use. The second thing is algorithms have become better, and as computing power and these algorithms have come together, they can actually solve a lot of problems much faster than they were able to before. And the third thing is with the digitization of all of the various activities. I mean, people are carrying these handhelds around everywhere. There's a lot of data that's available in digital form, which can be used to train models and build these algorithms that can be used to solve various problems. So all of these three things together are in place now, and 2018 is a great year where people can avail of cloud computing, algorithms that are open sourced, open data sets that they can use to train their models and bring them to bear on relevant problems. Okay, so let's talk a little bit about India now. And India is amazingly well positioned to capitalize on the opportunity of machine learning. Mobile data, with the work that Jio did last year, has become very, very affordable. People all over the place are using their Jio SIMs, they're using their JioPhones, and they are using data that like there's no tomorrow, but they're mostly using it to watch videos, which is great, but it can also be used to do many, many more useful things. Google launched Android Go edition last year in December again, and this is a specialized operating system which is built for low-spec devices, less than 1 gig RAM. And the reason we did this was there were a lot of low-end phones that would not run these applications correctly. So what we decided was that what we needed to do was build a custom OS where these applications would run well. There's no shortage of workforce talent in India. The IT industry has a number of people that can use these algorithms to solve interesting problems. There's also a very thriving startup scene. There's funding that's coming in, people that are interested, and very, very creative and innovative entrepreneurs who are doing very interesting work. And as we heard from Aruna this morning, there's a huge push from the government as well. However, there are challenges, and they are immense. The first thing is data. And data privacy and data security is a topic of great controversy as well as discussion in India. However, we need to also, as the government determines its data policy, they need to make sure that these data sets can be used for good applications. It's not just about security and privacy. There are anonymization as well as de-identification technologies out there that can be used to keep data secure as well as make it useful. The second thing is investment. I mean, there needs to be a lot more investment. Today, the investment in China is of the order of $3+ billion. In the US, it's of the order of close to $5 billion. But in India, the investment in these machine learning startups as well as technologies is less than $100 million. So as such, there hasn't been a network effect where an ecosystem has been built up, because both in the academics, although they are interested, industry is interested, as well as the government is interested, there hasn't been people coming together and working on these problems. I mean, the other piece is that in India, there hasn't been a big push towards robotics and automation because of the availability of people. So what needs to be done? So in terms of government policy, we need to enable creation of open data sets. I think that is very, very critical, because in order to build these machine learning models, they need huge amounts of good data. The government also needs to create programs like Make in India and Skill India and Digital India and so on, and there needs to be a program around machine learning which will create impetus for people to invest. The government also needs to increase its funding to academic research in these areas so that programs get set up where there are graduates who are coming into the workforce who are qualified to work in these fields. Just as in the 60s, I think at IIT, the one that I went to, implemented the first program in computer science, there need to be programs built for data science for graduates as well. And then the government, of course, needs to collaborate with the industry, which they are very much interested in doing, to solve societal problems like health and education. Also bring these technologies to bear on fraud and security and various other challenges. I think I need to go back one. Okay. Academia, we heard from the professors today on what needs to be done. There needs to be centers of excellence that are focused on machine learning. A lot of talent needs to be created, both by working with experienced faculty who have gained these skills in other areas, and as well as creating programs for data science in universities. And they need to set up partnerships with global institutions who are working on it. There's a number of them. And of course, help in creating data sets. Okay. Industry itself has a huge part to play here. We need to identify new areas to apply machine learning. Health is a very big one. Agriculture is one. Education is one. Fraud, security, so many areas. They need to transform these research challenges as well as work that's being done in universities into consumer products and make them monetizable, because this needs to be sustainable. And they need to build infrastructure which can enable startups as well as researchers to use these AI and ML technologies freely to develop products in the various verticals. I think this is an exciting time in technology, and this is a very exciting time to do these things in India, and I'm very, very optimistic that many companies such as ours, Google is very, very deeply committed to India, will drive work in these spaces in the coming years. Thank you.
Ms. Anjali Joshi, we want to thank you, and I personally want to thank you for that. And the reason, there is one reason, because I picked up the phone, like you, many people may not know. We decided on the show, to do the show, around 23rd, 22nd of December. And we really finalized that we want to go this route only on 28th. And then the planning phase started. So I have to thank her, Ms. Anjali, for not only coming because you believe in the partnership with Jio, but because you want to have the highest impact in India through that partnership. And we sincerely appreciate the relationship that you've been building with us in Jio, but the relationship that you're building on behalf of India to increase not just awareness about open source, but awareness about what we can do to change the lives of 1 billion people. Thank you, ma'am. I think she owes a big applause. Thank you, Ms. Anjali.
Thank you, Ms. Joshi. Thank you, Mr. Oman. With that, ladies and gentlemen, let's move forward to the next topic. Our next speaker happens to have a breadth of experience. In fact, he uses his business, technical, as well as open source experience to guide leading networking and telecom organizations to participate in and leverage open source projects to deliver rapid, disruptive innovation to their customers. Please put your hands together, ladies and gentlemen, to the Vice President of the Linux Foundation, Mr. Phil Robb.
Well, I'm very, very happy to be here. We've had so many wonderful presenters throughout the day. It's been very impressive to me to see the level of knowledge as well as articulation that the various presenters have had around open source software and its impact and potential impact on the digital revolution for India. Again, my name is Phil Robb, and as Vice President of Operations for the Linux Foundation networking projects, my real role is to ensure that I facilitate all of the different networking projects at the Linux Foundation are working as efficiently as possible to solve the needs of all of the different participants, large and small, across the spectrum of those projects. Before joining the Linux Foundation, I actually was the director of open source programs for Hewlett-Packard and started that program office and ran it for about 7 years. Joining the Linux Foundation, I became one of the founders and started off the OpenDaylight project. Helped also start the OPNFV project, the OpenO project, and most recently the Open Network Automation Platform, or ONAP project. So I want to talk a little bit about where we've come with open source. Matthew showed this slide earlier this morning. It's interesting because, as has been noted, we're growing open source at a really rapid pace, but I want to take a moment and ask the question, why? Why are all these people writing all of this software and giving it away for anybody else to use? It does not seem intuitive. And for many, many reasons, there are many different reasons why it's happening. At the Linux Foundation, we're seeing a specific trend that's really focused on industries pivoting technologies. When you have to do a significant rewrite of the existing infrastructure inside of an industry, we've come to the recognition that to do that together as an industry and then compete above that foundation is a much faster way to get there than trying to do it independently with every company. So So at the Linux Foundation, we obviously started with Linux. That was back in about 2001 when the Linux Foundation, or its predecessor, was actually formed. And that was the industry of computer companies coming together, wanting to basically address the needs of their customers. Their customers wanted a more uniform type of Unix-based operating system. Back in those days, I was actually a developer working in that environment, and I remember porting code to 13 different Unix platforms. It was very difficult. Customers were tired of that, so we brought an industry together. Hewlett-Packard, IBM, Dell, Red Hat was forming at the time, and we created an environment where those corporations could work together to actually solve the problems for their users and to build this platform that everybody was going to leverage. Since then, as you can see, we have an entire effort around blockchain with a project called Hyperledger, everything around containers, the container Container Native Computing Foundation contains both Kubernetes as well as Docker. We have a set of projects around IoT and embedded, including automotive-grade Linux. And then, of course, there's what's been happening in the networking space. And that's where my focus is. That started with OpenDaylight in 2013, so just about 5 years ago now. And after that, another project called OPNFV. Most recently, again, a project called ONAP. But point being that these projects, by and large, are less than 5 years old, and they've made a tremendous impact on the industry. Not only that, as separate component projects, but we're now coming to the recognition that they actually are starting to leverage each other. For example, ONAP contains OpenDaylight within it. It contains OpenStack within it. It contains Hadoop within it. So it's a rather large project to do orchestration of VNFs. We're going to hear more about that in a moment, so I'll leave that deeper discussion on ONAP for a later presenter. I also wanted to mention that, like any company, open source projects are very different. So just because it's open source doesn't mean it's done and governed and managed and operated all in the same way. So one of the things that you want to do when you're engaging with an open source project is first understand how you're going to be using that code. Are you just going to take it and use it and put it in your product? Or do you actually need to influence that community? Do you need to drive changes in that code base that serve your long-term goals? If it is the latter, you need to understand what the rules are for how you can actually contribute. There's a specific set of criteria that the Linux Foundation takes in that approach, and we call that collaborative development as opposed to just open source projects. So that governance and that culture that then is generated out of those communities is actually important because each open source project is indeed different. We had a presentation earlier on with regard to security, and similar to, again, how different companies address security needs of their own software, different open source projects do the same thing. At the Linux Foundation, we actually have a project around doing security scanning, doing security checks. It's called CII. I can tell you that OpenDaylight and ONAP both use a free service from a company called Coverity to actually scan our code for static vulnerabilities. And since both of those projects are also Java-based, we use another tool called Sonotype Nexus IQ that will tell us every third-party open source component those projects use, and if they're up to date with the reported vulnerabilities that have been reported out in the ecosystem and are provided in the CVE database. So in our projects, that's something we do, and we do indeed do scanning in the upstream in those projects. Specifically with regard to networking and where we are, I talked about a technology pivot that's necessary. And we see the industry right now in that position, right? To be able to support 5G, we have to be able to support thousands more devices 100 times the data rate, 1/5 the latency, and we have to do that tying all of the existing cloud services, residential services, IoT, and so forth with our infrastructure. That's a massive rewrite. That's not something that we can do with any of the software or hardware systems that we have today. So when I talk about a pivot of technology and one that's very focused on software, that's the type of change I'm talking about. And to do that requires a great deal of software. So for us to write that all together, write the foundational components together, and then compete at the application layer and specific service functions is really what we're shooting for. So this is how we see it with open network automation projects like ONAP, OpenDaylight, and OPNFV at the center of that. But we're also leveraging containers. We're also leveraging, again, cloud platforms such as OpenStack. Those are also key parts, and we have, again, an entire set of new foundational platforms coming out for IoT that will also need to integrate with those different components. So while each of those independent open source projects addresses a specific need, it is all just componentry of a much larger solution set. So we're talking, again, millions and millions of lines of code that if we all had to write independently as our own companies, it would take us far too long for any of us to actually do. So looking across the spectrum of the stack, starting from the hardware at the bottom up through the services at the top, again, over the last 5 years, by and large, most of these projects on this slide have come into existence. Right, so an explosion of activity specifically around networking in the open source realm. Now, some of these projects like OpenStack certainly have been around longer. OpenStack started in 2010. But OpenDaylight, ONAP, again, OPNFV, OVS was a little bit earlier, but FDIO, these are all going all across the stack, all independently trying to solve different point solutions, different point problems that different users and vendors wanted to create. And again, the interesting thing is that they are now leveraging one another in a very significant way. I want to talk about a couple of those projects and then talk about how, again, we're really seeing a relationship forming across these projects. So as open source evolves, as industries are engaging in a set of software tooling that they need to do this technology pivot, not only are we creating those point solutions, but then in the upstream, in open source, we're recognizing the dependencies across those projects and starting to form relationships to actually bring those together in a more holistic way, even before the vendors start to create solutions out of them. So briefly, talking about OpenDaylight. Again, this was one of the first projects, networking projects in the industry. 5 years ago is when it launched, but today we actually serve more than 1 billion subscribers across the planet. Meaning that, more than 1 billion subscribers receive their packets that are controlled by switches controlled by OpenDaylight. Another key aspect of a good open source project from the Linux Foundation standpoint is it does need to be a platform. It does need to be foundational. And by that we mean it has to be built in such a way so that it's easily added to. New features can be added in many different dimensions. And that can happen without too much crosstalk or too much interdependencies across those functions. And again, things can be added relatively quickly from a technology standpoint. We couple that technology aspect with a governance structure that also fosters the notion that anybody who wants to bring something interesting to the project is allowed to. Hence, as long as it's not going to be somehow significantly detrimental to the rest of the community, you just allow it. So that way, even if the function doesn't seem interesting to a majority of the community, as long as it's not slowing anybody else down from what they're doing, it's something that is allowed. OPNFV is a different kind of project. It actually was formed from the Networking Operating Council of the ETSI group. They had come to us, to the Linux Foundation, asking seeing that there are all of these different components, OpenStack, at the time OpenDaylight, OVS, and so forth, and they all had deficiencies for what the carriers were actually looking for. So they wanted to create a project that would actually both identify those shortcomings, put people in those upstream projects to make those features available, and then have an infrastructure to test that indeed those toolings were actually serving the needs of the NFV community. So not something that was actually building software, but one that was actually working with upstream communities to build features in other software and then testing that. So in the end, we see all of these different components coming together in such a way so that at the bottom layer, across the abstraction and the disaggregated hardware, we have projects like OPNFV, FDIO, and the Open Compute project working together to actually build an accelerated data plane. In the middle layer, we've got OpenDaylight, OPNFV, and ONAP actually managing the controllers that actually control the flow of network, or the flow of packets, rather, through the network. And at the highest level, we have projects like ONAP, Panda doing data analytics, and working closely with additional standards organizations such as the MEF and TMF to actually bring those together. So not only are we working in all of these independent areas, but we have a lot of synergies going on across those areas. That's what we at the Linux Foundation see as the next major activity that we expect to be helping to drive over the next couple of years within the networking industry. And with that, I thank you for your attention.
Thank you so much, Mr. Rob. Thank you once again. All right, ladies and gentlemen, our next speaker happens to be an open source enthusiast. He also loves designing and developing software hands-on. He leads the technology research and development organization at Reliance Jio. Please put your hands together for Mr. Ayush Bhatnagar.
Good afternoon. So today's topic is about having a more mature deployment of NFV and SDN, because we have been talking about NFV and SDN from different perspectives, from the developer's perspective, from an operator's perspective, but what does it take to bring everything together at one place, and what should be an overall architecture to deliver a mature and a scalable NFV deployment? So in this slide, what we have tried to do is to bring together some of the pillars of a mature and scalable NFV and SDN deployment. So at the very top, you have the virtualization technology. Of course, you need to have a good base and a good platform for virtualization, such as OpenStack. And then you need to have SDN and SD-WAN, which means programmable networking through SDN, and software-defined WAN for enterprise service delivery. These are the two next pillars. Then we have adaptive operations, because any NFV deployment without an adaptive and an intuitive and an automated network operations platform would be incomplete. That is the adaptive operations pillar. Then, of course, the management and orchestration layer that Phil also spoke about. That is, of course, a central component of your NFV and SDN strategy. Then the move to OCP and the microservices architecture. So all our applications which are going to be disaggregated, they have to move to the OCP architecture in order to scale elegantly. So that is the next pillar. And then, of course, we also discuss the maturity model from a processes perspective. So the rest of the presentation is anchored around these pillars. So the first pillar is virtualization. So here we have tried to logically stack all the projects of the OpenStack into a more logical and a more understandable format. So at the base, you have the core OpenStack services that most of the people know about and most of the people use. And on top of it, you have the compute plus services and the backup and restoration services. So the compute plus services like Magnum, Storelet, Zun, so these are something which are not so well known and understood by developers, at least the developers that I have spoken to. Then you have the backup and restoration part, where the freezer project is something which is of interest for us, especially for VNF backup and restoration. Then on top of it, you have the networking and deployment services of OpenStack. And right at the top, you have the projects which add the aspects of security, identity management, parallel processing, and big data to OpenStack. And on the right-hand side, it's a timeline of the evolution of the OpenStack project, right from Austin till where we stand today. So that is a timeline view. Moving forward, I put together a cheat sheet, as you may call it that, which shows what these components of the OpenStack project will deliver to you. So some of the interesting projects like Vitraj, which is for root cause analysis, this is something of interest for us as well at Jio, and we are closely following it. The Freezer project, the Watcher project, and of course the projects that enable integration with Chef and Puppet. These are some of the projects which will help us move towards a more scalable and a more automated NFV deployment. So moving ahead, we move to the next two pillars. So the next two pillars are SDN and SD-WAN. So what we have tried to do here is to create a stack view. So we all talk about SDN, we talk about the use cases that it will enable. Then we talk about virtual CPEs, we talk about SD-WAN in the context of virtual CPEs, we talk about a fluid transport network, but how does it look like when it comes together? So this is this view. So at the very base, you have your transport network that plugs in to the TSDN, which is a concept which is gaining popularity of late. Then you have your IP and MPLS network, which consists of old routers, legacy routers, which do not support RESTconf, YAML, OpenFlow, and you have the new breed of routers which are programmable, which have open interfaces. And these routers plug in to your IP SDN platform. And on top of it, you have the virtualized infrastructure, the virtualized networking infrastructure, which consists of the OVS, VCPE, OpenStack, Neutron, which goes into your VSDN controller, something like an OpenDaylight project, which was just touched upon by Phil. And on top of this, we have the NFV management and orchestration platform, which is ONAP, as shown in this particular chart, which is covering majority of the use cases for management and orchestration. Now moving forward, Phil touched about the OpenDaylight project and how it has made a big difference in such a short amount of time. So this chart has been borrowed from the Linux Foundation, and it tries to summarize the architecture of OpenDaylight. So for those who are planning to use this as part of their SDN strategy, the key aspect on this slide that we should note is the fact that it is extensible in nature. So it is extensible in nature right at the controller layer, at the interfaces layer, and also at the SDN applications layer. So SDN applications could be as follows. Automated provisioning could be one application. The VNF networking provisioning could be other application. The virtual CPE could be a third application. So we are free to write our own SDN applications and use cases on top of OpenDaylight and use its open APIs. Now we move to the next pillar. So this we call as DevOps 3.0. The term DevOps has been used and abused for a long time. But what this really means here for us is to have an automated and intuitive platform for enabling operations of a virtualized core network. So we call this concept as Atom. And as a matter of fact, there is an Linux Foundation initiative in the form of the Ecumos project, which has been announced lately, which also goes into that direction that we should focus more on the use cases based on the microservices architecture and leverage machine learning for having an automated network. So this is a very important aspect because apart from machine learning platforms that we see for data science and getting insights and solving other use cases, how do we apply it in the context of NFV and SDN? So machine learning in the context of NFV SDN is central to our strategy. Then we have the MANO layer. So MANO as an architecture as defined by Etsy, I believe all of you must have seen that picture on the top left corner. That is all right, but in order to deploy a truly scalable, feature-rich MANO platform at a scale that, for example, Jio has brought to India, you need a lot of enhancements and a lot of features and functionality on top of what is defined by HC. So this is a non-exhaustive list, but there are many more features that need to be added on to the pure stock MANO platform in order to make it scalable and in order to make it effective in a network as big as ours. Then this is the example of how a MANO platform can be realized. So we spoke about the ONAP platform, and in this chart we are trying to explain what the Amsterdam release of the ONAP platform looks like. So as we all know, there is a design time framework, which is the SDC on the left-hand side. Then you have the execution framework, where you have multi-VIM support, you have an SDNC pluggable layer, you have the common services of ONAP like the DMAP bus, logging, MSB, the DCAE for correlation. So the homes and the DCAE have been harmonized in the Amsterdam release, where homes and it was a pretty tough exercise, but I think we did well at the end. And at the very top, you have the ONAP Operations Manager, or the OOM, for the overall administration and management of ONAP in production. So this is just one example of a MANO platform and how this can be leveraged in the context of an NFV and SDN deployment. Then we come to the maturity model. So from an operator standpoint, what should be the process that we should follow from the journey of a software application from its bare metal avatar to a VNF avatar? So we basically follow two tracks. One is the design track and other is the integration track, which is shown below. So on the design track, the complete blueprint and the virtualization design of every software application is done. Then the application has to be onboarded through a platform such as ONAP. And after that, the build automation of all the VNFCs, or the VNF components as they are known in HC terminology, that needs to be part of the process. And then the packaging, deployment and orchestration through the actual MANO platform is the design time track. Then of course in the integration track, first you need the infrastructure. So that is where OCP comes into the picture. So if you don't have NFVI, then you don't have a place where the VNF can be run. Then after the NFVI, your VNFs need to be instantiated based on the day zero configuration, as it is called, the day zero capacity configuration. Then the technical integration, because whatever that was working in the physical world, it has to keep working when I virtualize. So all my call flows, use cases, integrations, whatever we had done so far has to be repeated. And then finally, disaster recovery, geographic redundancy between VIMs and all the method of procedures which should be automated through the DevOps approach. So this chart summarizes what the process looks like, and this is just another detail of the same chart. Now, the other part is how we leverage REST APIs, microservices, and OCP in this whole ecosystem. So as we virtualize our applications, we also have to go through a transformational approach on how we write applications. So the first tenet is the REST API concept, which was predominantly popular in the internet world, but now very quickly it is now coming to the world of telecom operators and also the carriers and vendors. Then of course the re-architecture of monolithic applications into discrete microservices, and as a matter of fact 3GPP has stopped calling them network elements, they've started calling them network functions, especially in the 5G architecture. And then the OCP architecture, which would be used for a dense compute and storage deployment. On the right hand side, this is a non-exhaustive list of popular open source projects, which I think most of the developers would have used, or they would be aware of these projects, which can kickstart your open source strategy. Then this slide is about the OCP, so the Open Compute Platform project. So here what I've tried to do, I've tried to logically display the various sub-projects of OCP and what exactly they bring to the table. So you need to have a reference architecture for OCP design, the interop standards, the data center design, the firmware, which is OpenBMC, rack management controllers, and the Redfish APIs, which are REST-based in order to talk to your MANO platform for auto introspection, for example, as a use case. Then the operating system, the rack design, the standardized compute and storage sleds, which make up the complete OCP, modular designed rack. So this is about the OCP. Then OPNFV. So Phil spoke about the OPNFV project and the critical role that it plays, but there are a plethora of tools which can be leveraged in order to create a complete test bench for NFV. So these tools are usually hidden somewhere under the OPNFV ecosystem, but we use these tools quite often. So the bottlenecks tool, which would generate a workload for VNFs, for your VNF and VNF components. Then the func test tool for functionally testing your NFVI and your VIM. Performance testing tools, the SDN controller benchmark testing tools, the object storage performance, which is very important. And for data plane applications like the PDN gateway, DPI, media gateway, you have the VSPerf tool. And then if you want to further extend your testing strategy by injecting faults, by writing your own scripts, you're writing your own test cases, then you can leverage the Yardstick project of OPNFV. And then finally, we have a list of open source projects that from a developer standpoint, from a network equipment provider or VNF provider standpoint, what open source projects can be used in conjunction to create a complete CI and CD pipeline, continuous integration and continuous delivery pipeline. So of course you have the Git project for source code version control. Then you have Eclipse, we all know about that. Fabricator is a tool which in my experience has actually brought down the time taken for code reviews, for the time taken for correcting what was coming out of the code reviews. So the Fabricator project is pretty good. You can create your own wikis also and bug trackers also. Then you have Jenkins, SonarQube for code quality checks and auto remediation strategies for improving your code quality and reducing your technical debt. And then finally, for packaging and deployment, you can have Docker. You can deploy Docker on bare metal. You can deploy Docker on a VIM using the OpenStack Docker bridge. Oops, sorry, I went the other way. So this brings me to the end of the presentation. If you have any questions, we can take them offline after the session. Thank you so much for having me.
Thank you, Mr. Bhagwat. Thank you once again. Well, before I invite our next speaker, we have two announcements, ladies and gentlemen. So we still have one more one more prize for the best tweet. So please go ahead and start tweeting using the hashtag IDOS2018. Apart from this, you will have received a message on your phones for those who had registered for the best ideas. Rather, we were giving you the prizes for the best top 2 ideas. So go ahead and start voting for the top 2 ideas. So we have shortlisted 4, and from there we're going to, based on the votes, we're going to give away the prizes to the 2 best ideas. So the polling has begun, and the polling ends at 5:30 p.m. today. So go ahead and read those ideas and choose the top 2 best ideas. With that, ladies and gentlemen, let's move forward. My next speaker is responsible for NFV SDN development at Samsung Mobile Development Business Unit, and he happens to be the Senior Vice President and Head for NFV SDN Cloud for Samsung, Mr. Soyoung Chong. Could we have a huge round of applause, please? Thank you. Thank you.
Thank you. I'd like to thank Jio for inviting me to this event. Very happy to be here. And I would also like to thank Ayush for making my job much easier. I don't have to explain what NFV SDNs are. He already done that. Oh, sure. Can you hear me better now? Okay, great. Okay, today there has been some discussions, a lot of discussion about disruption, innovation, transformation. So next 2 slides, I would like to show you what has happened in year 2017. The first slide is the world map of mobile network, mobile connectivity. The 4G is in yellow, mostly around North America and Japan, some parts of Europe and South Korea. This map was captured about fourth quarter, about September, October of 2016. Okay, please pay attention. What next one will do? Can anybody recognize the difference between the first one and second one? Oops, I got a little excited there myself. So, it's mainly because of you, the people that are here, right? India went from 2G and skipped 3G and went to 4G. Somebody talked about the term geode, right? Somebody coined the term geode. Next year, if you search Wikipedia for the term geode, maybe there may be a two picture. These two pictures can be in there and describe what the term geode means. Yeah? Okay, so a little bit more down to earth here, and talk about NFV SDN, which I don't have to explain. And just wondering as how much of NFV SDN is actually being commercially deployed. This term has been discussed for quite some time, right? So we've been looking around the data and talking to some consulting company. And one of the data I came across is that one of the consulting company went asked around 60 service providers from Europe, North America, and Asia, and asked how much of NFV SDN are you actually deploying? The areas that I'm interested in, because I'm from Samsung Electronics, Mobile Network Business Unit, is virtual core, mobile network core, right? Virtualized core. And the response came back is about 20%. 20% of operators say they are deploying NFV SDN technology. But this number can be misleading. Even if they have very small amount of NFV SDN deployment, the response is still yes, right? So this is not really 20% of their subscriber capacity, or not 20% of their throughput capacity is what they are capturing here. Okay, so I went through our experience of what our customers been doing. Okay. One of our customers started this journey about 3 years ago. It's lucky for us because they were forefront of the NFV SDN transformation. And currently, they're almost at 100% of their IMS capacity and almost at 50% of their EPC capacity as a virtualized phone. Another of our customers went through this transformation a little later, but they went through many more verticals. They went public safety LTE, private LTE, NB-IoT. They were all deployed in NFV. And also in recent announcement, there was a 5G deployment by Verizon. It's FWA, it's not mobile, right? 5G, the core as well as RAN are in virtual functions. So Samsung, we were lucky enough, we've been lucky enough to work with some of the operators that are in the leading edge of the NFV SDN transformation. Okay, if we ask around, I think Ayush showed some of this picture similar fashion, but if you simplify what Ayush described earlier, and if you ask around, how's your NFV SDN system look like at this currently? They will show you somewhat like this picture. Mainly three categories. One is in NFV SDN infrastructure or NFV infrastructure. That includes commoditized hardware, like servers, switches, storages, and Linux operating system, and hypervisor on top of it. And another one includes orchestration, orchestrator. That includes virtual infrastructure orchestrator and VNF orchestrator altogether. And third one includes network function itself, virtual network function, virtualized network function. Okay. Some of our customers tell me, so I asked them, so do you see much of benefit or any benefit going from hardware-based network equipment to virtualize network functions? What's your main benefit you see? They said they expected CapEx to go down, but they haven't been seeing it. CapEx stays about the same. They're spending about the same amount. But they certainly see decrease in time to deploy the service. Actually, it used to take them several months to deploy a new service. Now, the same process they go through is taking less than a month. It's still a long time if you look at it from the IT automation perspective, less than a month. But you know, if you understand the telco industry, it's several months or a year before that. It's much of a reduction. In our lab, we do the same thing, except the processes that operators need to go through. We do the deployment in few minutes. So that's the potential, going from hardware-based network equipment to software-centric virtual network function. You can reduce your deployment time to minutes, several minutes. Or in the future, maybe several seconds with a container. Another interesting use case that we've been seeing is that they're actually incorporating this NFV ecosystem into their SCM process. So they build NFV Open Lab, and they pre-qualify potential vendors. When the NFV, they need to put out an RFP, they use those vendor pools they already integrated with. And that makes their RFP cycle, the qualification cycle, test cycle, much shorter. So that's another benefit. They mentioned it to me. Problems, they say? What has been the problem with the NFV? Number one is lack of, I guess, unified orchestrator or lack of interoperability. Everybody talk about interoperability, but as Ayush mentioned earlier, with a standard defined by ETSI, there's some flexibility or lack of clarity between the interfaces that tweaks is necessary if to accommodate third-party solutions, right? And in some cases, it's not that straightforward. Another difficulty they're talking about is there's more complexity in the system. It used to be, in a hardware-based network equipment, it used to be, and I'm just taking an example as a Samsung, they can just tell Samsung that, hey, by the way, there's a problem. You guys go fix it if there's a problem. But now with the NFV, there's multiple layers, and there's vendors, different vendors per layer in many cases. Hardware comes from maybe HP, Dell. Linux comes from Red Hat. OpenStack comes from Red Hat, Mirantis. Right? VNF comes from multiple vendors. Right? Orchestrator can come from somebody else. Right? Now when there's a problem, all of a sudden operator have to figure out where the problem is. And they're not equipped to deal with such a situation. Now they have to pick a vendor to drive that, but pick who? Right? Everybody will say it's somebody else's problem. Right? Try somebody else first before come to me. So that's one of the biggest problems they went through. Okay? Network equipment vendors are not known to be very active in the open source community. But that has changed with the NFV SDN. Right? And Samsung also have been participating actively, especially in the areas that are relevant to NFV SDN. And Samsung hosts annual event, just like similar to this. It's called Samsung Open Source Conference. It's an annual event with about 50 presenters and about 2,000 participants. It runs about 2.5 days. And picture in the bottom is showing that. And picture on the top is an event that we held for ONAS. It's an ONAS build event. It's an annual event. Last year was the second. I think they go around a different region of the world, and their intention is to, to recruit more members. And we were fortunate enough, we were lucky enough to host that event last year. We had about 250 participants, and that includes hackathon, that's hacking code while somebody making a presentation. And so what is the next step in the NFV? I'll be focusing on the orchestration aspect. There's a VNFs, virtual network functions. There's various aspects, different vendors. And also orchestration is one area that our customers said there's problematic. There has been problematic. One biggest difference that next orchestrator will come with is closed loop control. That is necessary for 5G. 5G, as you know, is supposed to support multiple types of services. Therefore, need to support network slicing. Network slicing with the different traffic characteristics, service characteristic. If we want to support multiple services, multiple SLAs with a single common physical network, you need to have a closed loop. You need to continuously monitor network quality. You need to use that data collection and feedback to adjust your network, right? That is going to be the one difference from orchestration as we have today, and orchestration there will be tomorrow, next day. It's not future, but it's near future. And I think ONAP is trying to address that, and we are part of the ONAP community. After tomorrow, where are we going? How are we going there? The direction, I think, is very clear. We're going to the direction of autonomous network, self-driving network. Maybe it's still far away, right? But that's the direction that everybody's driving to. Right now, we are driving ourselves there, but pretty soon we'll be riding, autonomous vehicle to get to the autonomous network. But in Samsung, we are making small steps to get there. We are building use cases based on machine learning and AI. It's not autonomous network yet, but it's a steps to get there. We're building solutions to detect hardware fault before that happens. We are making solutions to plan RF, your RF planning, your cell site planning that is based on artificial intelligence. Those are the things that can be used right away. Right? And those also will be a building block to get to the autonomous network. Okay? So, if I summarize the evolution of the network virtualization, we're currently at is at the virtualization stage with the service provider. Our operators in that stage. But the folks that developing the solution, they're in the middle stage. They're actually talking about automation, although they haven't been commercially deployed yet. So ONAP is not yet commercially mature enough, right? Hopefully, this April release will be a little bit more mature, right? But everybody's working toward to that intelligence stage. Okay? So for 5G, how does that come into play, right? So I think the first two, the world map that I showed you, right? India, with a huge help from Jio, made a huge jump in terms of, going from 2G coverage to 4G coverage. I think India also have an opportunity, right, to go from all hardware-based network deployment to the software-centric network deployment to 5G in a much faster pace than other parts of the world. And NFV SDN, the virtualization, is not 5G only technology, but it is a building block for 5G. And especially for operators that are going to deploy 5G, NFV SDN transformation is necessary. That's what I have for today. Thank you.
Thank you so much, Mr. Chong. Thank you. All right, before we move forward to the next presentation, rather we're going to have 3 panelists join us. Would it be okay if I ask everyone to rise and shine for a minute? Just everybody. Yeah, come on. Everyone, just yeah. You can stretch if you want to. That's perfectly okay. Okay, so this is something we're going to do quick and short. We know binary 1 and 0, no favorites, but 1 is very simple. 1 is 1. 0, however, has got 2, which is, so when I say 1, you're going to do, when you say 0, you're going to do? All right, let's try. Let's see how much we are in sync, shall we? 1, 0, 1, 0. 101 101 1 0 1 0 0 0 0 0 0 0 1 1 1. Thank you so much. Thank you. Mr. Tariq, this is for you.
Thank you.
All right, yes, ladies and gentlemen, thank you so much for being absolutely participative. And thank you once again. With that, ladies and gentlemen, we have Mr. Tariq Amin, who will be coming forward and taking the next conversation with the other 2 panelists. Thank you.
Thank you. Thank you very much. Ladies and gentlemen, good afternoon. I certainly hope you have been enjoying this summit. Today I have learned a lot, and before I just give you the presentation, just my sincere welcome to all the leaders that travels abroad to come and share with us their thought around Digital India transformation. So with that said, let me share with you a bit of our journey in Jio. Firstly, as many panelists and presenters have talked about, as we talk about SDN, NFV, software-centric, you know, one must ask himself why. Well, if you're in telecom, you understand that you build network based on customer centricity. This is something that many telcos miss. See, as elegant as SDN acronyms, NFV, we're doing it for one specific reason. Full autonomous networks to identify real customer issues before customer complaints has been the ideal mantra of what every telco in the world are trying to achieve. So at Jio, when we conceived this blueprint and architecture of what is the network of the future might look like, well, firstly, we started from the customer first. Our blueprint even came from our chairman, and the chairman philosophy, every customer matter. He is not a percentage, he is an absolute number. A drop call do matter, a block call do matter, quality do matter. So the way we track this network, we said, look, we have to be completely customer-centric. This network must be built on innovative technologies that really foster innovation, built on top of open source component, whether it is radio access, whether it is core, and whether it is services. So to deliver services such as high-speed internet, voice over LTE, these things must be monitored in real time, and we must have this capability to address these issues as and when they occur without having the customer complain to care agents. Then the other thing is about intelligent OSS. We heard about this a lot, and hopefully in many, many forms, Jio will share how we are changing this world around OSS. I assure you, ladies and gentlemen, what we're doing in OSS is a fundamental transformation. Fundamental transformation. The ability to achieve autonomous network, I have no doubt it will happen in India, it will happen in Jio before any other operator do this. And it is largely because of open source activities and projects that we have embraced, and our ability to transform as an organization and open our minds and say we're going to change processes. And our team is absolutely committed to this customer journey and transformation. Driven all the way with our chairman, he says, I need to know how many people I have to call today to say sorry to. Just imagine this message. How many people I should call and say sorry to. So, bucketizing customers into logical areas to say bad, good, happy. This has been really a challenge. And look, I've worked for all Tier 1 US guys and Tier 1 operators in the US. I have never seen anything, and nobody have taken this step forward as much as we have done, but that only has happened because we embraced open source. And we embrace it in a very collaborative way. We think that is a much better way to engage and accelerate. So, parts of our transformation strategy is not only thinking about the software. So today we heard a lot of great topics that talks about software, hardware, and bundling or disaggregation. We've heard this a lot. Now at Jio, I will tell you how our DNA work. When we look at hardware, we want to make every hardware that comes to Jio a commodity. So this is a very big transformation journey, not necessarily only to Jio, but to the industry as a whole. This is an area that I assure you is challenging OEMs. And vendors have to find a way how to exist in this new, brave, software-driven world. So this concept of today, what I want to really focus on is this hardware-software segregation. And what do we really mean by this hardware-software segregation? Because it is absolutely the most important thing that we have to do as we carry this transformation. It is not only about core, it is not about using off-the-shelf component, but it is actually looking at the network as a whole and the devices that attach to the network and separating the hardware such that we derive and deliver efficiency to the end customer. So why we do all of this? Who's the beneficiary of all of this? Ultimately, our job and objective is to deliver a superior customer experience. We are after customer. We are fanatic about customer. If we deliver this at a breakthrough of cost structures, and we deliver at a quality, then we have accomplished the job. So beyond getting really caught up into the technicalities and the hows of SDN and NFV and all of the automation, firstly, we want to go from the bottom up, and everywhere from access to transport to core, we will absolutely derive and achieve this goal and objective of separating hardware and software. It is too important for our transformation. So I will not go through too much of this detail, but I'm going to tell you also my personal transformation strategy and opening my mind to think differently. Almost 4.5 years ago, I joined Jio from the US, and one of the first projects I took on with my team is to look at small things, small cell and Wi-Fi. And I always got challenged to say, look, what is the difference between Wi-Fi that I buy in enterprise and Wi-Fi that I deploy at the home? So the first part of this discovery is realizing this issue of supply chain management. Why this hardware-software segregation is too important is because once you understand the supply chain management of how you buy a good, from someone that manufactures this to how it gets delivered in the network to ultimately being consumed by the subscriber, you discover a world of an opportunity. And this is what I'm telling you, ladies and gentlemen, that this is a tough issue for OEMs to understand. But it is something that's going to happen. And I think there is an ecosystem in which hardware and software could exist. And this is the new world for OEMs. To help me just a little bit more debate a little bit of this topic, I have asked a couple of my colleagues that I came to admire quite a bit through my interaction with them to come to Jio. They flew from the US, and let me introduce the two gentlemen that's here to talk specifically about this hardware-software disaggregation. What does it mean to the industry? And how does that enable us in India specifically to really innovate, lead from the front, not from the behind? So firstly, let me introduce to you Mr. Ashraf. Mr. Ashraf is the president and CEO of Altiostar. And Mr. Manish, President of the Communication Services in Tech Mahindra. Well, gentlemen, I hope you've been enjoying this session.
Yes, very much.
Absolutely, Tariq.
So we're going to talk. I mean, honestly speaking, I'm going to tell you guys a secret. I met with them yesterday. We did not rehearse. So there is no rehearsal, but
Tell us about those slides, I wish.
But what I wanted to do is really talk from the heart to you about a very interesting topic. So Ashraf, I've been really tracking you as an individual for many years. You are a serial entrepreneur. You've been very successful about what you've done. So one might argue you should take a vacation and enjoy your time. Why did you start another venture?
Very interesting question. I enjoy challenges, especially when I see market transition that one could exploit by using technology. Starter Networks, my previous company, we saw the transformation occur in the core. There are two transformations that occurred through Starter. One was the technology itself. The gateway was intelligent gateway, much higher density. And we brought the cost per subscriber down from $30 to $3 to $1. But more importantly, we changed the way operators procure the gateways. When we entered the market, the gateways were bought in with the radios. It was kind of brought in, it was thrown in literally. So we had to change the pattern by which the operators bought those gateways. Instead of buying it along with the radios, we had to have them buy them separately. So we can sell our value proposition and be able to enter. Now when we entered the market was dominated by 12 giants. And they were literally, the gateways were like 5% of the total procurement. So through that experience, after Starland became part of Cisco, we also saw a much, much bigger opportunity. And that bigger opportunity is in the access space, in the radio itself. Today, as you know, the radio, the hardware, software is all integrated. Everything is custom. You buy from one company. And you have to accept what they give you. The innovation is driven by those handful of companies. You don't have a lot of flexibility to change the software that you get. So at Altiostar, our philosophy is to separate the hardware from the software. Make the radio software-centric, not hardware-centric. And make the hardware a commodity. And also bring the hardware from as many companies as possible so you can increase the R&D velocity. Instead of waiting for innovation coming from 3 or 4 companies, have innovation come from 15 and 20 companies. So you can multiply the hardware innovation to drive down the cost. The reason is obviously that the lower the cost that an operator has to spend to build a network, they can build better network, higher capacity network, higher throughput network. And that brings me down almost a full circle. At my very first meeting at Arcom, this is before RGO, when I was just started, I met JT Bhai. I don't know if he's in the audience or not. Okay. So he gave me a story that I still remember. And that story drove us as Starland, is driving us at Altiostar. He told me a story that when Dhirubhai decided to start Arcom, he brought his team together and he said that for us to succeed, the cost of communicating on the mobile network should be the same as a stamp on a postcard. Right. I hope you remember that, GD, right?
Very cool. Wow. Wow.
So that drives me.
Yeah, very good. I mean, let me tell you, very inspiring. I assure you, the area that you are taking, we're very, very committed to. We want to really segregate software to hardware everywhere. So I commit your energy and passion, and I love the story about JT too. Amazing. I could completely sympathize with what happened that day. So Manish, I think one might ask. So in this process of changing the supply chain and the economics of how an operator might go to an ODM and purchase products and goods directly from an ODM and software that would come from someone else, then what one might argue, the complexity of who owns the end product. So in your opinion, what's the view of the role of the system integrator in this equation?
Thank you, Tariq. By the way, going back to Ashraf's, your previous question to Ashraf, I'm glad that he did not retire or is retiring, because as you know very well, and as Matthew was kind enough and gracious enough to tell everybody, that this morning we decided, Tech Mahindra decided to get very close to Altiostar in this journey towards continuing the virtualization, disaggregation, network of the future dream that you very rightly presented on your slide number 1. So we at Tech Mahindra are extremely pumped up about what the future will probably hold. And to your question, I think in many ways with what you have done here is what inspires us and gives us the confidence that the future is extremely bright for a system integrator like us. If I were to use an analogy, many of us here in this room are avid travelers. We obviously take a suitcase and we go from one place to the other. It's not easy to find the thing that you want in your suitcase. It is always the last thing that you find. That is because things are not modular, things are spread all over the place. I think what has happened in the industry over the years is software and hardware, as they have been one, have become so monolithic, so large, so complex, so unwieldy, that it has been difficult for somebody to go and find the problems and solve those. With the disaggregation approach that you have taken, it makes our job as a system integrator very easy at one level. One, we can now go to the experts who do their thing the best, rather than people who know almost everything and yet do not know everything at the same time. So the role that we play now, as the world becomes more and more software-centric, is to try and imagine this future needs and the problem statement, as somebody said in the morning, is to start looking at the problem statement not from the perspective of hardware or software, but how do we really sit down and work together with the ecosystem, which is now simplified at one level because it is disaggregated and modular, and put the solutions together to achieve the end state goal. So from a mere technology integration company, we are excited because now it's a business problem integration company, and that opportunity is really presented, amongst others, because of the disaggregation of the hardware and software.
Excellent, excellent. Ashraf, I have another set of an idea that's always puzzled me. Yesterday I was watching on television, and an ad came about. Actually, I watched quite a bit of Netflix, and it came about talking about the percentage of engineers and scientists that are of Indian heritage that are working in the US now is approximately 36%. Yet when I look at telco as a vendor, why in India, in your view, we don't have an OEM vendor of an Indian, built indigenously in India? So since we're talking about moving India forward, I really would love to get your thoughts and view about what are the barriers to entry to move this, this journey forward.
I think it's a matter of mindset. I think the talent is there, the expertise is there. As Starter Networks, we did about 2/3 of our development in India. The most complex element of the network, something that is called an SDN in the 2G, 3G networks, was completely designed in India. We ended up deploying the technology in more than 300 tier 1 operators. Most complex element. And we were the first, Starter was the first company that developed an SDN that it was not a radio supplier. Similarly, at Altiostar, the complete software that we have today that drives the radio network has been developed in India.
Excellent.
It's designed by India, developed in India.
Excellent, excellent. I think this is tremendous. We want to see more of this. I mean, in the spirit, hopefully we'll host a lot more of these sessions in the future. My last question, Manish, I met you in Facebook Telecom Infrastructure Project in Santa Clara. And one of the things that I know you've dealt, and Facebook is one of your customers, what is your view when you compare web-scale companies, whether it is a Facebook, Amazon, Google, versus telcos? What do you observe the main differences?
You know, I think there are many points of differences, Tariq, but the one that comes to my mind at this point, I have often, so I run the strategy and the business for Tech Mahindra in the telecom, media and entertainment space. And mind you, media and entertainment was an afterthought. It was an afterthought because we realized that the telecom companies will have to move towards the vertical integration in terms of going where their services go, which is what you are doing. And as we studied that business, one thing came out in our face and actually worked to our advantage, to our core, but we learned it very quickly. We said if I were to put on one column of the table, all an amazing set of companies, some of the major telecom operators that have served the humanity for years in one column. Also put along with them some of the other older companies, automobile and others. And on the other, just maybe put 2 or 3 web scale companies. The market cap of all of these companies put together pale in comparison with just a couple of them. So that was one thing that we observed, and we said, let's find out what exactly is going on here. Not an easy answer, but one thing stood out. It is the way that these companies curated, wrote, architected their software. developed their software. So at the very core of the web scale and of the disruption, no surprise, is software. And now we're talking about intelligent software, cognitive software, and take it from there. So from our vantage point, I guess the one big difference that we see from our customers on the West Coast and the customers elsewhere, good news is though, Tarek, is, one has to give a massive salute to what Jio has done. You guys are the spearhead in really saying it is not just in the West, it can happen in as east as possible in India.
Yeah, Manish, I agree.
We definitely believe that.
No, so look, I mean, I want to give you a summary. First of all, I cannot stress enough my sincere thanks to coming here. It means a lot. And hearing this from you in the spirit of what this summit is all about, pushing us ahead of the curve in terms of digitization. And as we've heard earlier, this country does not lack talent. We got tons of software and IT developers. So again, please put a warm hand of applause for these two gentlemen. Thank you.
Wish to. We can take a few questions right now. 1 or 2 questions, if there are any.
Now that we stayed back, you better ask some questions, please.
Seems like they're going to take the questions offline then.
I answered all of them, actually.
Fair enough. Thank you. Thank you, Mr. Ashraf. Thank you, Mr. Manish. Thank you, Mr. Tariq. Thank you once again. With that, ladies and gentlemen, let's move forward. Our next speaker is a wireless industry veteran with more than 18 years of experience, and he happens to be the co-founder and president and CEO he was a co-founder and president and CEO for Paradeep-led Special Filers, the mobile next generation networking market leader to broad success across the US market. We have with us, ladies and gentlemen, the CEO and president for Mavenir. We have Mr. Paradeep Kohli.
Well, thank you. I was coming here actually for a meeting with Jio, and Matthew called me day before yesterday saying, okay, we have this summit going on, and we would like to talk to you about how carriers can use open source to innovate new services. So I thought I'll come and talk about, what it's actually, it's an interesting topic, first of all, because carriers have been losing this game for, I think, last 20 years. And if you look back, when things were very well defined, there was a PSTN phone, plastic phone. You had a dial tone which carriers could offer. That service, you totally 100% nailed it, right? You pick up, dial tone came, everything worked. And then it was, 1G, 2G services. It was a feature phone, or it was not even a feature phone, 10-digit numbers. All you could do was make a phone call, maybe short SMS. It worked great. I think the game started changing when and until that time, of course, network was smarter than the phone, because network was telling phone, you can only do these 5 things: voicemail, SMS, MMS, make a phone call, and that's it. I guess 10 years ago, iPhone came, Android came, phones became smarter, and that's where actually carriers lost the game. Because now the phone has become smarter than the network. And in fact, actually the other problem is that your competition has changed. So I've been kind of in the industry since 1990, working for the vendors. I'll talk about it a little bit, but it's actually a very difficult problem now because carriers are regional. Like Jio, okay, you're the biggest operator in India, and of course, but you're still serving Indian market. But you're now competing against companies like Google and Facebook who are serving worldwide market. So they can actually take their R&D dollars and spend on services which they can take to the whole world. And they are adopting open source, and they are taking new technologies. And on the other hand, the carriers are actually, not only they are regional, like AT&T or Verizon, even if they are big, they're still only 100 million subscribers.
versus, Google and Facebook can do billions. But on top of that, you have another problem. Or actually, we together have another problem that I think Yush and other players before me, other speakers before me talked about all the Linux Foundation and all those open projects. But we have a boat anchor called 3GPP, where 5-6 vendors get together. So if you look at Ericsson, Nokia, Samsung, whatever, right? 5-6 players. They have probably 1,000 people within that company. So maybe put all of them together, maybe 5,000 people get together and determine what is best for all of us. So they determine that, okay, 5G should be done like this. And they sit together in very fancy hotels, very nice places, next to beaches. And of course, they come together and figure out a 3GPP spec, which then only they can develop. And only they know how to answer those questions because they are the one who came up with it. And the rest of the whole world has to follow it. So in a way, actually, it's a very, very unopen, right? There's no openness about this whole industry because the way it is constructed. So we can, unless we change the game from the very beginning, we'll be only playing on the edges. You can do, like all the examples which, Ayush pointed out, Mr. Chong pointed out, they are still on the fringes, right? You took an SD-WAN and made it open, or EPC made it open, but the biggest money which you spend in the access space and the connectivity space is a closed circuit and very difficult to penetrate it. So I think unless that is cracked, it'll be very difficult for a carrier to achieve the same level back again. Right? So I think I'll talk about, of course, the services part, but I would like to encourage, I guess, the Linux Foundation and other people that when maybe carriers cannot do this. So what if you did a competing game to 3GPP saying, let's open up who can come up with the best algorithms for improving the spectral efficiency by 5 times. And if you made it an open source project and saying rather than 3GPP following, come up with algorithms, come up with this mechanism, come up with the formats and all that stuff, and open it up to hundreds and thousands of people. And I bet you they will come up with better answers. They're better from all the machine learning algorithms, all the natural learning things which Google uses or Facebook uses. Just imagine if you all opened it up to scientists and signal processing engineers who are in the universities and PhDs and all of that stuff, they would come up with a lot better than what 5-6 companies working together can come up with. So I think in general, there's a lot to be done. What we have been doing so far is still on the edge. It's still not solving our main problems. And the main problems have been more in the area of how this whole industry is very closed. So with that, I will just give you a quick, as Mavenir, we of course provide the core network. I will skip some of this part. But I think the issue is, just a quick, with Mavenir, I guess we had a company, or we bought a company called Eldiscon. And they were the first one who in 1995 did SMS. Because there's 2G on Vodafone network, there was the first SMS done in the whole industry. Of course, if you look about it, if all we have been in the industry, a lot of us, 20 years ago, and WhatsApp came and captured the whole thing in such a fast manner. And the reason they were able to do that because they didn't care about interoperability, they don't have following any standards. It was a peer-to-peer, and they just had a global market to themselves, right? Versus, I was showing it to Tariq. I come here, I turn on my phone, I'm a T-Mobile subscriber. I can't connect to Jio network, even now, here. Because there's no IoT done, there is no VoLTE roaming, there's none of this stuff done, right? So it's just the nature of the carriers by themselves cannot learn how to get away from themselves and open it up, right? So some of it is, I think, overall, the ecosystem and the knowledge base is not there. And the more difficult part for the carriers is going to be that things are going to get even more difficult. See, so far, just imagine, this phone was smaller than the network, but you're still dealing with phone. It has, it can do a lot more things, but it still has a certain requirement. It has, what battery is, what modem it does, and you're dealing with you built a network for one type of device. With 5G, it's going to be a different ballgame because now you have different type of devices. They will have different requirements on the physical layer. They will be addressing different use cases, right? Which means that now it has to become more flexible. And I was hoping at least, okay, I thought as part of this industry, right, that maybe in this transition people will get smarter. That they won't do this thing the same way the 2G, 3G was done or 4G was done. And it's exactly happened the same way. We wrote 5G specs written by 5, 6 vendors, Google, Facebook, none of those guys participated. It's done same players, Ericsson, Nokia, Samsung, Qualcomm, all those same players doing it exactly the same way. And it's going to become another cycle of this doing the same thing, right? So I think that's where, I believe there's now an opportunity that with the amount of people who will be using these networks and the amount of flexibility is required, then what Tariq is doing and all the work of separating out the software and the hardware will become even more important. So if you look at, I think, other speakers talked about it before me, and there are a lot of initiatives in the open source space, but they're all towards, after you're automating the network, reducing your cost of running the network, after you have deployed it in a proprietary way, right? It's one of those things that, the house is already built and you're figuring out how to polish it in a more flexible manner, right? And keep it clean. So to me, that's where most of the initiatives have been, and nobody has dared enough to solve, okay, where do I spend most of my money and how do I make that flexible, right? And that's where I think, more work needs to be done. And that's, I think, because all these initiatives which are there, they are, of course, dealing with some of it is in the management layer, some are in the automation layer, some are in the transport layer, right? And they are also not addressing, the key, as I said, the key elements where you spend the money. So why it needs to change? Of course, new services are required. As I said, you'll be dealing with new sort of devices. Those devices will have new requirements, right? And it cannot be all addressed with the same way that people were doing it in the past. Of course, vendors anyway, there are very few left. And that's another part, right? In the past, people thought by being very close, they'll protect themselves. Everybody's hurting. Look at Ericsson, Nokia, everybody's hurting, right? So it's not that it really helped them. In fact, it is, it's like suffocating the industry itself, the whole closeness. So the more people become open, it actually makes the industry more vibrant. Because then, people innovate, people do new things, and everything goes, when tide is high, everything goes up. Right? But these are somehow sitting in their little shop and thinking, okay, I have 10,000 people, I have 20,000 people, I can do better. But they're competing with a lot bigger forces out there. So I think for us, the whole issue is going to be, okay, even if, on the vendor side, people change, the issue is also on the operator side. I mean, I think what you presented and other people presented, a lot of this stuff is very complex. See, in the past, right, you were used to, as an operator, dealing with boxes that, okay, you bought a BTS, you bought an MSC, or you bought an E Node B, an S gateway, P gateway, and you're done, right? And now all those things are split apart into 15 layers, and, there's a, name for every little layer you have, neutron, proton, extron, whatever, right? I mean, so you saw 15 acronyms. By the time somebody figures out, you're already done PhD, right? So you say, and that's not easy. And, and what we are seeing is that only the big companies, so AT&Ts can afford it, Verizon can afford it, Jio can afford it, because you have internal teams who are knowledgeable, you have the engineers and all of the stuff. But this whole thing is really not designed for somebody to easily adopt. And until it comes to a point where people can just, adopt it the way they're used to adopting it, or the knowledge base either goes up or the requirement for the knowledge goes down, it will be very difficult for this whole ecosystem to really work. Again, so far things have been working with the industry consensus comes more, when the people define 3GPP rules. But in reality, those are 95% done. The 5% is left to imagination, and there is really no interoperability among number of vendors. And there's a lot of issues regarding intellectual property as well. So I think the three areas where I believe there is a potential. So ONAP, I think you should also covered, there is a automation layer. So the whole idea is that, as the networks get bigger and bigger, and you have a lot more devices and a lot more people using it, the way, say, Google or Facebook or other Amazon run their networks, they're actually running it with very few people. They run the whole data centers with a lot less people. Versus today, if you look at AT&T and other big companies, they have lots of people who still they need to manage the networks. So bringing the whole network cost down, running it in a more automatic way, detecting the problems fast enough, self-correcting the problems, healing the network itself. So there's a lot of things we can actually use from the open source and the ONAP project to make that work. Similarly, we are participating in the XTRAN project, and this is where I guess our previous speakers here, separating out the hardware and the software and making the interface, open. I mean, just imagine, yesterday Tariq was saying that he would like the actual eNote B to come down to $2,000 or $3,000. Every time I talk to him, it goes down by $1,000, right? So it started at 5,000, it became 4, now it's half every time, right? But just imagine, I was looking at these projectors, they're probably more than $2,000, right? I mean, and it's like that speaker, but just think of this way. I don't need a 3GPP spec to feed data into this projector. People know how the hell to connect their laptop to this projector, and it works. But today, to connect hardware which sits on your tower, you need a 3GPP spec to connect that thing to a computer which will be running the baseband, right? And you cannot make it open, you cannot dismantle the two, you can't buy it from two different vendors. And this is the biggest crooked scheme I've seen, right, in any industry. And this is a big industry, right? I mean, and it's like there used to be 7, 12, 15 players. Now there's 3, 4 players left, and somehow all the big operators can't dismantle them. You keep buying from the same people that's doing the same thing, right? And somehow waiting for a different result. So I think unless operators themselves change and figure out, how to open it, nobody can solve this problem for you, because, you don't encourage innovation unless you somehow dismantle it yourself. Why don't in your own, RFPs, you ask for that I'm not going to buy from somebody who doesn't have the damn interface open, right? But so even AT&Ts of the world can't get it done, right? So this is where I think for operators to adopt the openness, you have to ask for openness. Because in the previous, I think that in the morning, the discussions we had, that unless the government tenders have requirement for open source, it won't take the, encouragement and initiative. And that's where I think some of these things will only be adopted if you ask for openness and you tell of different vendors you had that, okay, in the past I was doing things this way, but now I really want to be done in a different way. So I believe there are opportunities where you can actually, rather than, because I think, the services game is lost. Let's call it that way, because I don't think for service providers to innovate in the services space on how certain things get done, from like the way Facebook does, or how do you build a social graph. You're not going to build a Facebook again. You're not going to do a WhatsApp again. You're not. I mean, so at the end of the day, that games is gone, right? And it's okay. Now your game is mainly, okay, you've got all these devices who have all these requirements. You have all these service providers who want flexibility. So they want low latency, high speed, low cost, better predictability, better quality of service. And you have only this much spectrum, only this much cost you can afford, and you cannot discriminate because you have net neutrality and all of that stuff. So that means, how do you become intelligent enough and reduce your cost? And the other thing which I keep, when I go talk to operators, is that in the past, right, when it was 2G, 3G, you were buying networks for 10 years because things stood for 10 years. Now things were not changing fast enough, right? Now if you look at between, when was 4G built so Jio launched it last year here, right? And people started using it. In another couple of years, they'll be talking 5G. Similarly, so the pace at which things are moving are actually gone very fast. And you cannot hold on to the same old principles. So I think this is where, I believe that the whole concept of radio needs to change. and the way, and that's what I think Ash's company and our company is doing. The way the enterprises network are going to use the network, no matter what, you'll be forced to change, right? Because enterprises will want, Wi-Fi is obviously solving certain problems, but it doesn't give you QoS, doesn't give you predictability. And also, like in this building, you can actually have your own private LTE network, which is better QoS than Wi-Fi can offer. So these are the kind of things you can use open source to build it. And there's a lot of issues on, when the way that networks are structured today. You basically, all the traffic comes into the core, you have everything comes into the EPCs, which are far away. It has very high latency requirements. And so as the traffic grows, you may actually have very simple white boxes sitting on the edge where you can just do a local breakout. Similar to what cable companies do today, right? So there's not much. You need to start becoming like cable companies and start thinking that way, that I got a bunch of these devices was going to, attach to my network, demand all this. So obviously there are areas where open source can still be used and things can move fast, but the bigger areas, I think, unless you change, it'll be very difficult to adopt all this open stuff. Thank you.
Thank you, Mr. Kohli. Thank you once again. So yes, ladies and gentlemen, from getting perspectives on opportunity of open source by Mr. Kohli, we now move forward to understanding the missing piece for successful transformation to cloud. We have with us the CEO of Voyager, who comes with many years of experience and having held a number of senior positions related to cloud software development and sales. Please put your hands together for Mr. Patrick Lind.
Good afternoon. Really great to be here. Today we have listened to many speakers speaking about the role India can take in open source. We have also had many speakers that have spoken about the top talent here in India. So I just wanted to start by telling the story about our company. Matthew, in the beginning, started to say that Stockholm is one of the innovation hubs in the world. And I'm coming from Stockholm. But what we've done here is that we have started our company and co-founded our company together with Arif here from India. Many of you are active in telecom, I hope, and then you know the role that Arif is playing in the open source community. He's one of the key drivers here in India. We heard Phil that was speaking about OPNFV, and I totally agree with it has been very, very important for the telecom industry going towards open source. And Arif is one of the OPNFV ambassadors on a global level. So this has been the starting point for us here, and it has been, for us at least, something that has been a very, very successful journey. What I will be talking today is something that I consider, or we consider, a missing piece. And I'm doing that because when we're going open source, there are certain things that are fundamental in order to be successful. And I have, for the last 6 years, been working with open source in a telecom context. I've been working with cloud infrastructures based on open source in a telecom context. And I've been doing this for half of the time as the CEO or founder of this company. And prior to that, I was doing it from Ericsson. And Ericsson was, at that point, the 5th largest software company in the world that took a decision that everything should be moved to open source cloud infrastructure. So that has, of course, been an interesting learning. And what I would like to share with you here is what I think maybe you could bring home and do something with. When I speak about telecom is, on one hand, normal enterprises having very, very important customers and very important enterprises to attend the service for. But it's also a machine that is delivering, or a network that is delivering a service. And this network that is delivering a service is slightly different because it's coming from an extremely standardized industry that has been working for 140 years in standardization. And of course, when this started to happen in 2012 with the ETSI, NFV, etc., that made a huge impact on how these organizations, suppliers, operators, etc. worked. So when the original equipment or the original hardware and software that was being sold by vendors like, for example, Ericsson, but also Cisco that is co-hosting this today, etc. It was a challenge to think about what will this with cloud mean for us? And particularly, what do we need to do in order to be successful? And I put up Amazon as a picture here. And Amazon has done one thing very brilliantly, and that is that they have offered a consistent platform that has enabled innovation. A platform that you have a service catalog, you know what to buy, you can actually create the applications on top of that. And that was something that the telecom needed to keep, because otherwise you don't get the innovation. On the other hand, you had the telecom technology complexity. So you needed to keep the Amazon, but you still needed to do it. One thing that many operators around the world have selected is that instead of going public cloud, they go private cloud. And one other thing is also, which we have heard with Reliance, but also the AT&T and the other ones, is to select open source. But I'm going to talk about now the important dimension of how do you get this to work. What we have seen is that you have the hardware and software integrated. You want to move to the other side. And that is, of course, a technology change. But it's also very much more than that, because it is the matter of having a common cloud platform for all these applications that are running on it. And this is also an organizational dimension. It's also a dimension of keeping a consistent SLA from an organizational perspective. When we work with operators around the world, in addition to the technology transformation, they're actually also reorganizing. Because they're saying, we want to have a consumer and a provider part. We really want to adopt this cloud paradigm. Because internally then, when this application should have the possibility to be installed quickly, you need to have someone that is the provider of this internal cloud. Someone that lives up to the SLA, someone that actually guarantees the service catalog, so we can innovate. And that is a thing where there is not enough focus, according to us. This is the same picture as the previous one. It's just showing the point around that you want to have hardware and software separated on a common cloud platform. But there's one very key important dimension here, and that is that this is not only coming from internal suppliers innovating on a platform, it's also coming from suppliers. It's also coming from external companies that needs to know what do we get, what kind of platform do we get in order to get this to work. And the problem I'm coming to now is you want to have an open platform, but we have not well enough defined what are we giving to the applications. And if we're not guaranteeing this, if we're not promising an application a certain set of functionality, KPIs, etc., how can they guarantee that it will work? Of course, you can try to bring in a system integrator, and that can in many cases solve the problem, but in many cases, based on our experience, it is not possible. Because it is so that you haven't put enough requirement on the underlying cloud platform in order to actually have the possibility for an application to work. And that is something that we have seen is one of the key barriers for operators specifically to go from smaller deployments to a dependable network that you can depend on. We had our Samsung friend here speaking about that despite the fact that many things are deployed, still there's many that is resisting to move over the traffic. And if you don't know who is responsible for what and how should this actually cooperate, you do not have anyone that actually guarantees that it works. Our view on this is very simple. You need to adopt the cloud paradigm, meaning that you need to demand from the cloud platform a specific set of KPIs, functionality, etc. then you can ask the application, this is what you get, you need to promise our performance. OPNFV, for one, is working on this, which is very positive, of course, and they're doing things within this area. But there's a lot more to be done in actually to really succeed on the cloud transformation, according to us. And based on the experience both from being a vendor for 3 years, but the last 3 years being an independent player in this area. So basically, the operators are having 4 choices. One is to say, oh, this is becoming too complex. Now we separate the application from the cloud platform. We don't do it. Today there are very few operators that are saying that. Most of them say, we will go ahead and do it. But they're still saying, we wait a little bit. Then there are other ones that are saying, okay, but maybe we can create islands. Maybe we can do an integration of this application with this cloud platform, an integration with this one with that cloud platform, and an integration with that one, and create numerous islands. But based on experience, what will happen is that soon you have actually create silos once again. Then the third one is to hope that things work and work it out, which is, of course, not so attractive. So the last one is actually to try to work this out. And here you can see where the telecom is as of today. And that is that a few of them have reached all the way as an industry. Thanks is once again courtesy by OpenNFV in this one. But even the ones that has reached there have had the challenge to migrate all their application workloads and all the traffic on them. So, last but not least, what is our learning out of this one? We think that it's fundamental that you create a clear accountability between the applications and the cloud platform and require certain performance from it if you want to go operational and move over all your traffic. And that is something that impacts everything from procurement, design, operation, all through the process. Here we have seen certain operators moving into this direction, but there's still quite a lot more to do on how do you actually create this accountability. The other thing that we think is fundamental, you need to have a service catalog. You need to actually have an internal vendor that is promising certain things for the application vendors or for the internal innovation or for whoever it is. Otherwise, it's very difficult to actually succeed on the cloud transformation. And last but not least, it's automation. Automation is fundamental because we know the innovation that is happening in the open source area. We know that we always want to capture this, and if you don't have a CI/CD process or automation in testing and automation in how you deploy things, it's going to be very difficult to achieve the benefit. Very good. We as a company, we work to try to help on this. Specifically what we're doing here in India is that we're developing a software product to do this. We are an Indian-Swedish company with global ambition and with a purpose to make this happen. Thanks a lot for giving me the opportunity to come here.
Okay. Thank you so much. Thank you. All right, ladies and gentlemen, before we move forward to the next set of presentations, we had promised that we have some exciting prizes for some lovely contests that came up during the summit. So yes, we do have winners, and let's get the prizes flowing. We are generous enough to do that right now. So the first one, ladies and gentlemen, is the best idea. In fact, we did receive the 2 best ideas. Those have been voted by all of you present here. But we're going to first give away 1 prize and 1 little later. So for the best idea to present this prize, may I first invite Mr. Arun Sursa. Could we have a huge round of applause, ladies and gentlemen?
You know, I know it's towards the end of the day, and anytime I interact with Mr. Arun Sur, favorably, lovingly, called as our Sursab in all respects. And I can assure you, I don't have the 48 years of experience Mr. Sursab has. But I can tell you, in my 28 years of experience now for myself, I can't believe that. It's 28 years since I started my journey. I have never come across a gentleman who's so passionate about his work, committed about his work, and dedicated with the highest integrity. And I'm proud to say here that we are extremely blessed to have our Sursab with us for the last many years. And it is an honor for this event to have him here to give the award for the best idea, because this man has brought so many great ideas to this organization and its success. Ladies and gentlemen, I think it's extremely important if we would all stand for a minute. It's good for our health. And thank Mr. Sur for what he has done for India, for telecom, for Reliance, and for the people of this nation. Thank you, Mr. Sur.
Thank you so much, Mr. Matthew. All right, ladies and gentlemen, so let's find out who the winner is. We've got two winners, but one of the winner is Chandra Shekhar, the CTO of Fast Lane Information Technology. A huge round of applause, ladies and Thank you so much for doing the honors, and congratulations. All right, so let's do one thing. Shall we also announce the best question that we have received? Do we have the winner, Mr. Prashant Rajankar, here? All right, we do have him. All right. Could I have Mr. PK Bhatnagar join me on stage, please? All right, so I think Mr. PK Bhatnagar would have gone out. Mr. Ricky Bindra, request you to kindly join us on stage, please, to present. So we've got the Samsung S8. It's over here, sir. To Mr. Prashant. Thank you so much, Mr. Bindra. Congratulations. Yes, we do have some more winners, but we're going to announce that a little later. So let's move forward, ladies and gentlemen, to our next presentation. We have with us the CTO of Mojo Networks. In fact, Mr. Praveen Bhagwat is going to be presenting the next presentation, and he is a wireless networking pioneer and an accomplished researcher. Ladies and gentlemen, could we put a huge round of applause, please, for Mr. Praveen Bhagwat.
Thank you very much. Actually, I love coffee as much as you do. And I want to get to that coffee as fast as I can. So I'll promise that I won't keep you away from it for too long. First of all, thanks Reliance Jio for giving me this opportunity to present my story with you. Especially the opportunity of Wi-Fi in India at massive scale is such a great opportunity for me personally, and I'll tell you sort of my personal story, that why I'm so excited about it. Back in 1990, I was a grad student, went to US to do my master's and PhD, and we had these big workstations we used to work with, and some of us thought that, someday computers are going to shrink in size and we are going to need a replacement for this Ethernet cable. So why shouldn't we be thinking about how to take an Ethernet packet and put it over unlicensed wireless? So that thought process was triggered in sort of early 90s. And I was lucky that after my PhD, I ended up joining IBM T.J. Watson Research, the world's kind of premier R&D lab, and the very group which was building that toy technology to put the Ethernet packet and take it and put it over the air. So the picture I'm showing you on the left is the first prototype we built in 1995. And it was like the first unlicensed 900 megahertz wireless LAN. And we got very excited when we were successful in connecting two devices. We took the idea to IEEE. They were kind enough to form a working group called Air 2.11. And now we see how big this technology is all over the world. And particularly in the context of India, the opportunity is so big. So for me personally, being part of the early team, building the toys, which have now grown to a form and shape where we are sitting here to talk about Digital India, for me is a very, very enriching and exciting journey. But if you look at how the market over time has evolved, the IEEE has done a great job in making sure that over the air, any device can talk to any access point. The interoperability has been maintained as the standards have gone through evolution of 11B, 11A, 11N, 11AC, AC Wave 2, and so on and so forth. But if you see behind the access point, all vendors are kind of working in their silos. There is really no interoperability behind the access point, the network management layer. And if you talk of scale, this is the opportunity that we have, that, there's a talk of BharatNet, there's a talk of smart city Wi-Fi, public Wi-Fi, all the operators are rolling out, hotspots throughout the country. The scale is too big. And that scale is very hard to build and architect using the traditional ways of doing networking. And we all heard so many stories of why there's a need to move away from proprietary hardware to more, virtualized network functions. So clearly the time is right to do it. Now, if I have to maybe succinctly kind of convey my sentiments and thoughts, some of you who may have seen the movie Wall Street, Michael Douglas has a very famous quote saying, "Greed is good." And inspired by that quote, I want to say, disruption is good. Open is good. Because it is a disruption and open which creates a new landscape, the new opportunities where small players like us have a role to play, to innovate and bring new ideas to the market, to really push the technology and create new possibilities. And I want to talk about 4 specific innovations that we have brought to the market, thanks to Jio for giving us the canvas to exercise our creativity and bring those ideas to the market. So the first one is cloud. The scale that we are talking about, millions of access points managed through a single console, just extremely hard to do using the traditional controller-based architecture. While the cloud, which you can build using elastic software architecture, you can build using commodity servers, you can push more and more intelligence to the edge, is the right way to architect it. And I think I'm really glad to report that the entire Jio's Wi-Fi, or a good part of Jio's Wi-Fi cloud has been built on a cloud architecture, and we have been sort of enablers of really making that vision a reality. So as opposed to stacking up the hardware boxes, you essentially completely virtualize the management function in the cloud. Once you build the cloud, it creates a completely new sets of possibilities that you can start tapping into the technologies of big data, AI, machine learning to build an amazing carrier class experience. Now, why do you need this? Well, all of us would be very familiar with this picture. That's oftentimes when we use, things don't work, we blame that, Wi-Fi is crappy. I mean, the common user perception of airport Wi-Fi and so on is that it's crappy. And if you're building such a massive scale Wi-Fi networks, you really can't live with that user perception. So how do you architect a system which delivers a carrier-grade quality to the end user? And I think the solution lies that you use big data analytics to proactively detect issues and correct them. In fact, some of the previous speakers talk about the evolution. First you virtualize, then you automate, and then you self-correction. And we are glad to report that the slide which you saw earlier, which was a concept, we actually have implemented that vision in the context of Jio Wi-Fi. And to tell you at a very high level how it all works, we have instrumented the access point state machine to a very minute level. All the other conditions that we can see, we catch them and we, using the cloud technology, essentially trickle all those logs and information into the cloud, store it into a big data platform. And when you aggregate these error stats from such a large number of access points, you can start seeing trends. You can start seeing where the issues are and proactively start detecting issues. So just to give you a feel for what I'm talking about, here's a screenshot of a live deployment. You can see that at 30,000 clients, I can pinpoint exactly where the issues are. The issues are at the association level, the issues are at the authentication level, or the issues are at the DSCP level or DNS level. It usually takes days or months of troubleshooting using traditional methods to get that level of clarity. But if you apply big data, if you apply machine learning, you have the power to digest that large amount of data and distill these trends and proactively detect these issues and correct them. So this is not just a concept, but we have built this technology and applied it into the real deployments. And that's the reason why Jio Wi-Fi delivers a carrier-grade experience to the end users. Now, this technology doesn't stop here. We are today collecting about 200 KPIs. And across any KPI, we can do anomaly detection. We can figure out where the variations are happening. And the moment you sort of spot any weird trends, that's an alarm that something is going on. And even before a user complains, you can proactively go and figure out what's going on. So that's the power of big data applied in the context of such networks. And I'm glad to report that Jio has given us the opportunity given us the platform to really deploy such creative ideas in the live network. And in the context, I would say, we had a discussion on, how to promote more entrepreneurship. I really want to compliment Jio because the very thought of the company that they're disruptive, they want to experiment, push the envelope. That's the sentiment which creates the fertile ground for startups to really come and deliver their value. And I think I'm really thankful that Jio has given us that canvas, and we have really taken the opportunity and created a technology which has not only potential in the Indian context, but it has a global potential all over the world. And in fact, I will say this is one area where what we are doing in India is actually not first in India, but actually the first in the world. In fact, the scale of the network which has been deployed, I would say, is probably the only network which is managed through a single console across the world. I don't think there's any other bigger network in the world today. So it's not only India first, but I think the world-class innovation can happen here, provided the right fertile ground and the conditions are made available. So moving on, once you have a big data platform, anything that you see in our management console, any piece of information, you can query the system using open APIs and get the answer. So nothing is proprietary or nothing is closed in our architecture. And once you open this API interface and you combine this API interfaces with other open services available in the net, some amazing new value you can create. I wanted to show you a video, but because of a technical problem, I can't play it right now. I would say go to our website and see a demo of how we have built conversational interfaces into network management console. You can talk to our UI. You can ask queries and get the answer, because Alexa will interpret your voice. It will translate your voice into an API call. That API call will pull it out of the system and play it out. So we are really pushing the envelope and showing what's possible in the future by tapping big data, by tapping open APIs. And finally, there's been a lot of talk about hardware and software disaggregation. And I will not dwell on it because we are all waiting for the coffee, and I think Tarek has already mentioned, had a panel on it. We have worked very closely with Reliance and brought this idea to the market. We are a very active player in OCP as well as in TIP. And those of us who are familiar with OCP, ONI is the key layer which allows you to disaggregate hardware and software. We have taken the lead in the open source community to port ONI layer onto Wi-Fi access points. So our vision is that you can source any commodity Wi-Fi access point, load the software on it, and build a carrier-grade Wi-Fi network. So at this point, I'll stop. We are essentially architecting the future, sitting right in India. Our 100% engineering is located just about 100 miles from here in Pune. Any of you are coming there, stop by, see our office, and thank Jio for giving us the opportunity to exercise our creativity. Thank you.
Thank you so much. Well, yes, ladies and gentlemen, we have 2 more presentations to go and 1 iPhone 10 to be given away. So stay tuned. Let me now invite our next presenter, who's a veteran in Apple, and he recently joined Siena. Ladies and gentlemen, please put your hands together for the Senior Director of Open Source Systems Office of CTO for Siena, Mr. Ranjit Ramachandran.
Yeah, I was kind of expecting a coffee break too, but I guess, a couple of us stand between you guys taking a break and us, finishing these presentations. So, my topic today is the role of open source for network orchestration in a cloud platform. I work for Siena. I wear a couple of hats, but, mostly focusing on, open systems. My team closely works with ONAP, OpenDaylight, ONOS. Before that, I spent, quite a bit of time at Apple. I joined, I wore a couple of hats, but, primarily involved in data center architecture. Before I left, I was wrapped into a bigger team, that was responsible for delivering cloud architecture that powered, Siri, iCloud, Maps, for Apple. I held a few more, positions in the Valley before that. From an open source standpoint, I'm a board member at ONOS. It's the Open Network Operating System. Again, we have talked about it. And we co-chair a group called the Disaggregated Transponder and Chips, which is, part of the TIP community. I think a lot of, we have a lot of presentations here are focused on orchestration. I think I'm not going to repeat a lot of it. A lot of great content here already. I think I'm just going to go through, a little bit, I'm going to keep it a little more simpler than that. I'm just going to go through a little, a background around why orchestration and automation existed and, the phase where we are in right now, how it all started, right? So this is, generally the first generation networks. Things were far simpler, right? We had, 1 gig servers, 10 gig servers were just, rolling in. We had a couple of data centers at best. If you had 2 data centers, one was your primary data center and the second data center was disaster recovery. Those were the good days, I guess. But, you had, far less systems. But quickly, we evolved into this, right? And I think, a lot of things just changed the game over the last 10 years, right? There was the invent of the smartphones. There was, all the cloud providers and cloud connectivity. There was content being delivered, online. And the internet capacity in general just increased, multifold. And so the skill sets or, the way we were looking at networking completely changed, right? You were looking at, you saw that, cloud was getting decentralized, right? Security was getting decentralized. You saw a lot of orchestration projects, no more were workloads running on bare metal servers. You had, Apache Mesos, you had Kubernetes, you had OpenStack for all your virtualization workloads. Hardware started getting disintegrated, right? As you scaled massively, you needed, most of the vendors looked at the cost and they said, how can we control cost? How can we have more control over how we deploy? So disaggregation came into existence. And just the way we deploy software, right? Emergence of SDN started, right? You started having a common control plane. You wanted a single pane of glass for your forwarding plane. So things just changed drastically. And, I think, from a networking standpoint, right, gone were the days when the skill sets was around, BGP or how you do your MPLS networking or how many OSPF areas were there. It quickly changed focus to how do you do software-defined networking, right? How do you virtualize because of the number of networking components you actually needed to run in your network? How do you do NFV? How do you make APIs so that you could, you could do event logging, you could do monitoring, you could control your software from, from a UI, right? White box networking, right? Did you know how to deploy, disaggregated software and hardware? Did you know how to deploy CentOS-based OSs, right? And automation and orchestration, right? The single reason why we are talking about automation and orchestration, I mean, you can talk about the various benefits that automation and orchestration brings, but really the single most reason is scale, right? You look at, many times the number of devices. I showed a picture of class networking. It just increased 50x times the number of networking devices you brought into your network, right? Things just changed so, so dramatically. You had, so to facilitate all that, we continue to see the emergence of a lot of consortiums for networking. Open Compute Project, right? How can we make sure we leverage a common standard to build hardware? OpenDaylight, how do you leverage a common standard to build an SDN controller across, multiple platforms, right? ONF, how do you build an open networking operating system? How do you have an orchestrator that can work across multiple software and hardware resources in your, in your network? So a lot of this evolvement happened precisely to tackle the scale of the network that we were building, right? So, I think, again, we always tend to, talk about automation and orchestration. I think I like to keep it simple. When do we automate? When do we orchestrate, right? I think we automate. Oops, I think I fast forwarded. Okay, how do I go back? Okay, so in a simple way, I think, when you have to create a network, when you need to deploy, a topology, right, that's when you automate, right? That's when you use tools like Puppet, Chef, ONAP, right? All those tools are precisely there for you to create a stable transport network. Moving over to orchestration, when you want to create, a layer 2 VPN service, when you want to create any kind of service that you then run, it assumes a stable network, right? When you want to run a service that pans across your entire network, that's when you orchestrate a service. And to that effect, you have, multiple open source projects on either side, right? That's driving all of this. But again, right, I think we are in an era where we have moved on, but we are still on the left side, right? And the ideal dream for us is to get to the right side, right? We have a lot of different systems that are powering different parts of our network. You have your network management system that's, powering your MPLS code. You have a controller that's powering your cloud data center. You have your, another NMS that's actually powering your optical. It's still very disaggregated, it's still very disaggregated. And the vision, the future is that you can use it all to understand that it's a single forwarding plane over which you run services. And you need that NFV orchestration. I think, it's again, it's an exercise that everybody has to go through, but I think we'll get there. It's just that we are on the left-hand side, right now, and trying to move towards that. Again, I'm not here to say which one is better. I think there's been a lot of, conversations about the benefits of open source, about how you need to still work on integration, how it fits into the overall ecosystem of networking. So, at least from, from an orchestration standpoint, there seems to be at least 2 or 3 options developing. One is, your monolithic standard where you're vertically integrated with a vendor. You have your open source. It still requires customization, but, there is a lot of opportunity there for you to make it, a multi-vendor support. And there are also the system integrators, right? I think, one of the software that Siena delivers is Blue Planet. And it's built out of open source components. And the idea is that you go into any of the cloud providers, telco providers who are trying to orchestrate, they have Cassandra as a service. They have Hadoop as a service. And the idea is that you build an application stitching those services and then deliver that functionality over to the customer. Right? So again, right, it's all about choice. What are, as an organization, what are you looking at? And, some of the key open source projects, again, for orchestration, I think there's, enough has been said about ONAP. I think it's a great opportunity. It's a great tool that will fundamentally see a lot of, functionality getting into all of the organization. Open Network Operating System. CORD, I think we have talked about it a little bit. CORD is, it's a little different, but again, it's using all the data center principles that have come over the last 10 years, mainly from the OTT players, and trying to build a central office that resembles a data center, right? The virtual OLT, Siena is very, passionate about it. We have worked very hard on the virtual OLT. Those is, same with OpenDaylight and OpenStack. OpenStack, just is used pretty much in a variety of places. Anywhere you need any virtual machines, any virtual network functions, OpenStack's there. OpenDaylight seems to be the default SDN controller of choice from an open source standpoint. So, again, from a conclusion standpoint, I think there is a great synergy for open source networking right now, and that's a very positive development. I think there's, having worked in the cloud space before, there's obvious comparisons between how, an open source project like Cassandra or Apache Spark or Apache Hadoop have made it, its way into the application space and how it's very popular. I think the biggest difference from a networking standpoint is that the network ecosystem needs to be completely tightly integrated. So it's not, if you look at the LAMP stack or if you look at the Lambda framework, of how you do batch processing and streaming. You could use you could use Hadoop, you could use HBase, but you don't have to really, stick with HBase. You can use Cassandra as a key value store. You can use Spark. So I think that flexibility that a framework gives you to plug and play multiple solutions, I think, the networking, the ecosystem of networking has to evolve into that. More proof of concepts again. I think, from a takeaway standpoint, it kind of, dwells into what I was about to say next is, you cannot, I cannot emphasize this enough. If we are, if from an open source standpoint, you learn more as you deploy more. That's just the fundamental learning experience, right? Start with smaller components of the ecosystem, right? I mean, you don't have to do it all. You can take a smaller part of the network, implement open source. That's how it's always done, right? If you look at rolling open source into your environment all at once, it's going to be a huge task on your organization, right? Define where to, from an architecture standpoint, I think, one of the speakers talked about it. You'll have to define the architecture and where the open source components actually fit. Maybe there are certain segments of your network where open source is not nearly, it's not really, viable. So you'll have to define the architecture. You will have to define it yourself. And, continue investment in software in both development and contribution, right? It's key. You keep, that's how you get the mind share of whatever project you're in, right? Prioritize your open source contributions. You saw the list of open source projects, right? It's impossible to contribute and maintain an active state in every one of those, right? Again, it's going back to the start small, aim big, but, you'll have to prioritize this, as you start into orchestration, for example, is machine learning and AI important, right? How are you going to create the data sets? Maybe you look at a smaller function of orchestration to start with and think about machine learning 2 years from now. I'm not saying, what is the right choice and what's not, but, what I'm trying to say is if you are, if you're actually committed to doing open source into your network, you'll have to aim small and you'll have to pick which one your organizations, can benefit immediately and then take it from there, right? So that's really it. Again, I wanted to, thank, Jio for this opportunity. I think it's a great phase. Just coming from the Valley, just seeing and hearing so much about open source is really very exciting. I did not know that, US was so much down the list. Maybe, the Valley consumes more than we give back, but it's certainly exciting to be here, and I thank you.
Thank you so much, Mr. Ramachandran. Thank you once again. Well, ladies and gentlemen, we have one final presentation, but an important presentation coming up. By the Distinguished Services Engineer for Cisco, we have Mr. Jeff Apker. Could we have a huge round of applause, ladies and gentlemen? This is the final presentation. A bigger round of applause. Thank you.
Well, congratulations to you all for sticking with all these presentations, and you've stayed for the best one. So I'm going to talk about something that we've done to death in the last couple of hours, disaggregation. I work for Cisco Systems, so we're going to look at it from the point of view of the network and how it affects the vendors. We're not too worried about this because we're used to disruption. We're still here, we've been here for 30 years, and this is just a little bit of a bump. It's not a problem. But it's a very interesting issue, and I'm just going to give you a little bit. It's only a few slides. We'll be out of here in 15 minutes. And I'll give you a little bit of a taste on what the issue is. So first of all, we need to understand the market. And the market is sort of divided into two bits. We've got the web players, or the web-defined network guys like Google and Amazon, LinkedIn, etc. And they have very simple featured boxes that they run their code on and do very simple things. Compared to Cisco, where we have big boxes and lots of features that no one uses. So that's a problem because the more features you have, the more likely you are to have a bug that you didn't know you had because you didn't turn that feature on and you're wondering why is it like that. But we're not Robinson Crusoe in this area. All the vendors have the same problem. So that's the first part. But this lower feature business drives the left side of the graph, which talks about disaggregation, or separating the hardware from the software. So you have a lower feature box that's running on a white box. The software itself is running on a white box. If you look at the blue lines there, that's what we estimate the market to be by 2020 for very simple boxes and disaggregated boxes. So lots of very simple boxes, and half of the things we'll sell will be disaggregated. So what do we mean by all that? Disaggregated is taking what we do today, which is the monolithic type integrated systems, where we provide the operating system and the hardware combined together, sell it to you, and everyone's happy, sometimes. So what we do to disaggregation is that second column, where we take a white box of some sort, off the shelf, maybe it's Cisco, maybe it's not, and we put someone's software, maybe it's Cisco, maybe it's not, on top. That's the first part. Then you can actually move along to the third column, where you can separate the software within the stack. And you might say, well, if I'm going to run my operating system, my network operating system, on top of a Linux kernel, well, Linux does telnet access, Linux does syslog. Maybe I can take all that stuff out of the network operating system, let someone else do it. That way, I don't get kicked in the pants when something goes wrong, it's the Linux guys. Then you can go to the next level, which is that last column, where you say, well, I want the BGP module from these guys here, and I'll take the ISIS module from these guys here, and this module, you start to play around, and you can do it at every level. You might use someone else's ASIC, a different power supply. So you really modularize. So on the left side, you've got absolute control of what you want to do. On the right-hand side, you've got feature richness. You pick which way you want to go. In between. So what is a white box? Because all of that stuff runs on a white box. It's pretty simple. It's basically it's off-the-shelf hardware. It runs a third-party operating system, and it's generally Linux-based. And it has a bunch of modules in it, the power supply. It's got a board management controller which manages the fans and all the electronics inside. A little server, some sort of microserver that manages the switching ASIC, keeps all the MAC addresses and the routing and all that sort of stuff. And there are lots of people that make ASICs, as you see there on the diagram, from Broadcom to Barefoot. So there are manufacturers of white boxes out there. You can buy one off the shelf and then play with it and do anything you wish. And this is the first part of disaggregation. This is the hardware part. These are all the current white box manufacturers that aren't the incumbent vendors. So Cisco is not on that list, Juniper's not on that list. That's not to say maybe one day we will be. As President Trump says, let's wait and see. Why, as a customer on earth, would you want to do any of this? It seems all a little bit too hard. You know, you don't go and buy a car and say, I'll just buy the chassis and I'll put someone else's engine in it and I'll get some tyres from somewhere else. Why would you want to do that? Well, that's a good question. You're the customer, you tell me. This is what we guess you think you want to do it for. The first thing is it gives you leverage over the vendors to say, well, I can actually choose that box or that module or this BGP, and it gives you leverage to hassle the account manager, right? That's one of the things. It also gives you that choice of moving around when you wish, and so you have complete control of the supply chain. The next part is it's theoretically easier to automate because you're using open software, you're using Linux toolkits, it's all well known. There are lots of... what we're seeing a change is, if you look at the web players, if you look at the Googles of this world, they don't have network guys running the data center, they have IT guys. And the routers and the switches are starting to look like compute platforms because they're segregated. So all of a sudden the network guy and the IT guy become the same person. Very fat, chocolate bar, pizza. That's the only similarity between these two guys. But we can merge these individuals into one super individual who can run a compute platform or a network platform, makes no difference. And the last bit is self-determination. And what we mean by that is maybe one day a faster switch hardware comes along. You can just pop out the old switch hardware, put the new one in, put the same software on, or vice versa, and away you go again. So you have complete control over what you want to do. And this is what we think you guys want to do. Just a very simple example of something called Jericho, the Broadcom Jericho chip. Has anyone heard of this thing? Broadcom make the ASICs that go into nearly every network switch. Cisco uses a lot of Broadcom off-the-shelf silicon. And Broadcom developed a chip called Jericho, 2015. Why is it called Jericho? The walls of Jericho. Break down the wall. What wall are we talking about? We're talking about the network routing wall and the data center switching side. This ASIC can do both. Normally, an ASIC is designed to do switching or routing. If it does routing, it has a bigger buffer pipeline. It's far more complicated and very expensive. Jericho can do both. So you say, what's the big deal? Well, for the web players, it's really interesting because you can build a hardware platform on the left-hand side that collapses the access, the aggregation, all the routing functions into one layer called a universal spine. This is chaos for Cisco and others. We have this sort of hardware already that we can provide as a universal spine, but this is opening it up for everyone else. So you could just get this ASIC if you're a hardware vendor, and away you go, and you can collapse the whole thing and put your own operating system on. And this is what the web players are doing at the moment. So this is a bit of a challenge for the incumbents. The other part that's very interesting is over the years we've had special languages developed for all different types of chips that are out there. The one we're all familiar with is the first one on the right-hand side, which is Java, which can control the CPU. You get it to do what you want to do. The next one is the graphics language, OpenGL, not CL. You've got signal processing languages. You've got the machine learning languages, TensorFlow. Each of these languages can control the ASIC. Very deep control. Now, we've never had before, but we have now, at the network level, P4. And P4, you can create your own control protocol inside a data center and tell the ASIC to look for it and switch at switching speeds instead of it having to come up into the processor. This is a big deal. Programmable ASICs that you can write a human machine-readable language. So now the programming languages are at every single level and every ASIC. Going up the stack, the way open software works and open source works is you have all these layers. You have an abstraction layer which actually hides all the complexity of the switch that's below it. And what you can do, if you're a large company that has a very specific function, you can write your own code as an application, as an applet that sits inside the router and does what you want it to do from a routing perspective. What do I mean by that? Let's say you have a very mission-critical network and you know that the weather is going to be bad on a certain day. You could actually write an application to reroute at the high level around this area, do a preemptive reroute based on the weather. You could write an application to decide which data center of yours has the cheapest power at this time. You start moving workloads around based on how much it costs you. And you're not getting the network vendor involved, you're not configuring anything, you've written an application to do it. And this is what open source allows you to do, and this is what disaggregation allows you to do. It's a very, very powerful feature. So any use case you can think up, you can just stick into the router and away we go, into the disaggregated switch. This is the ecosystem for disaggregation, the open source ecosystem. You see a bunch of boxes there. Basically the boxes are the software providers right over there on the left-hand side that are creating the network operating systems. I forgot to mention, if we go back to this slide, can you see the network operating system in the blue box is sitting alongside the applications? 2 minutes. So you have the NOS doing all the hard work, but the apps are sitting there saying to the NOS, I want you to do this, I want you to do that. Just like a nagging wife, you know, someone's just in your ear all the time saying, turn left, turn right, you're driving too fast. That's the app. NOS is me. So over here we have the software providers that write the NOSes. There's a whole bunch of them, Cumulus, SnapRoute. You've got the silicon vendors that are making the ASICs. You've got the white box vendors that are putting it all together. You've got the Linux Foundation who have got virtual switches software. You've got up there the Open Compute project that are coming up with a whole bunch of standards, and those standards are here. For example, OCP's job is to try and standardize between the layers so that you can easily write your own network operating system and sit it on top. They've created something called ONI, which was referred to in a previous talk, the Open Network Installation Environment, which allows any white box switch to boot any network operating system that applies with ONI. That is pure open source play. And so it's all standardized. And this is opening up a Pandora's box of opportunity for anyone who wants to get into the world of networking, but add business decisions and functions on top of it business metrics. And so you're now routing based on not just what's the quickest route, but based on the weather, based on power, based on the number of people that are at a certain spot, etc., etc. It opens up an incredible amount of opportunity. So in summary, disaggregation is here, it's here to stay, it's not going anywhere. We're moving into the world where the networks are starting to look like the compute platforms, where you buy a laptop and you stick the software and operating system on it you want. And that's the model we're getting at the moment, we're seeing. You're getting APIs at all the levels. Disaggregation allows you to upgrade the hardware and the software separately. It allows you to negotiate better pricing. The world's your oyster, basically, from a disaggregation point of view. And programmability right down to the ASIC. So that's it. The last presentation. I hope you found that interesting, and I thank you for listening.
Thank you so much, Mr. Jeff Apker. Thank you once again for a fascinating presentation. Well, ladies and gentlemen, we started off really well, but even the closing is going to be amazing because we have with us our very own Mr. Anisha as well as Mr. Kiran Thomas. I would request both of you to come on stage for the closing address, please. Could we have a huge round of applause, ladies and gentlemen? Thank you.
Can you hear me? Can we have the presentation? We have a small one. Sorry, it is not the last one. Maybe that's the second last one.
Jeff, that was not the last one.
Great. So I think, thank you all on behalf of Jio for coming here. I'm assuming you had a wonderfully productive day. And the summit is all about open source. But what we really want to do, you have heard a lot about open source, but probably it is worth mentioning for a few minutes as to not how we do things, because I believe open source is a way that you do certain things, but it's also important to understand the why behind we do open source at Jio. So therefore we didn't say open source at Jio, we said open at Jio, and we will probably take a few minutes explaining what it all means. So at the end of the day, I think after all these sessions, probably we can all agree. This is one thing, one statement we hazarded, we put it out there, hoping that all of us can agree with this. Right from the first presenter, I think everybody has kind of touched upon this theme, that open source is the foundation for India's digital transformation, right from policymakers to all the vendors to obviously all the speakers here. And we have the same belief also about Jio. And Jio is a big part of bringing about India's digital transformation. And we believe that even open source is going to be foundational for even Jio's own digital transformation.
Hold, Kiran. Since morning, we are all hearing about open source. And we are hearing about how important it is for the country and how it's going to do good for the industry. But I have a question. Okay? Question is, tell me how open source is relevant to Jio. Very specific question. I mean, since morning I'm hearing about open source software, and Jeff has explained in very detail how it disaggregates. But how it is relevant to Jio?
It's a good question. That is why I said we want to talk about the why of open source. So we have a very unique definition of open source at Reliance and at Jio in particular. But let me first start by saying what it is not from our perspective. So open source is not equal to open source code. I think there is a little bit of an implied word there. When people say open source, they tend to probably think it is open source code.
Oh, I thought open source is open source software.
Yeah, well, software, code, etc. But in our belief, I think the words are correct, but the missing word is not code. But I think what is really true at Jio is that we have to be open at the source, not open source.
Elaborate this, I don't understand.
Okay, let us have a go at it. So open source for me means much more than open software or open code. Being open at the source, which is what really enables all things open to happen, including open source software to happen, is that we have to be truly open in our own minds. If you want to bring about an open society, we have to think about changing mindsets and making it open. We have to bring about open ideas. We have to create an open culture, open behavior. We have to be an open enterprise. We have to talk about open architectures, and we have to talk about open business models. And that for me is what it means to be open at the source.
Okay. This is good, but I think we need to dwell more and explain each one of this.
Okay, go ahead. So let's talk about open society. Open society is really Jio's purpose, right? If you think about what Jio has done in the last 1 year since we launched, we believe that we have to bring about the digital lifestyle for all of India. And being able to participate in this digital lifestyle is truly what creates this open society, where everybody has got access, everybody has got equal opportunities. And this digital democracy has been powered by a few disruptors, and again we heard about disruptions. And what we have done really is, again, among carriers here, maybe we are not very popular for doing this, but we made voice free. We created a whole bunch of powerful media and other applications. We gave it away free. We created content, and for the next foreseeable future, we have kept that free. We have even created a free JioPhone for those people who cannot afford a smartphone. You give a deposit, use the phone, return it, get the deposit back. So it's literally a free phone. We have launched the lowest tariffs in the industry, and obviously we worked with a lot of partners to even bring down the price of smartphones in general. All of these efforts have translated into the fabulous achievements that I think Matthew spoke about early on this morning, 100 million in less than 170 days. And we are well on our way to creating this open digital society. Let's also for a minute talk about the next aspect, which is open mindset and ideas. This truly is our mantra, right from our first business. How many of the people in the audience, and possibly the Reliance guys are not allowed to answer this, but how many of the people in the audience know what was Reliance's first business? Hand up. Spice trading, that's right. Not too many people know it, but we started with spices. And from there we went to polyester fabric. From there we went to petrochemicals. From there to refining. From there to then oil and gas exploration. Further back to the first telecom revolution in 2002. Then to Reliance Retail, and now here with Jio. So what is really common about all of these themes and all of these successes that the Reliance family has had? The idea is that we have to take the best ideas no matter where we find them. And we have to live and die by the strength of our ideas and not just be wedded to the fact that we have invented it or somebody else has invented it. This is true the spirit of open source. To quote our founder chairman, Dhirubhai, think big, think fast, think ahead. Ideas are nobody's monopoly.
Okay, so now I get it. And open culture, I think this is something which we started in Jio from day one. Right from our leaders, they are all in open office, easily accessible. And as we say, culture has to start from our workplace. Truly inspiring, everybody is completely sitting in an open office and accessible to everybody. So that's about and how we begin our open culture. Yeah, behavior, I think principles of openness are very much there in our values, Reliance values and behaviors. Customer is the center of our business. Integrity, very important. And one team, which is very, very relevant when we are doing collaboration in openness. So open behavior is something which is part of Reliance.
Great. Talking about open enterprise. Again, I think open enterprise is really part of our history. That is how Reliance and Jio was created. If you think about the picture shown here, our founder chairman really opened up big enterprises for small investors to participate in. And we really created the equity cult in India. You can see the small investors lighting up. That is what really started the Reliance story. And the fact that we have to be open to participate, no matter whether it comes to raising money, whether it comes to finding the right partners, whether it is reaching out to customers. At the heart of it, we still believe that the common man on the street is as much a part of our enterprise as any employee who works for Reliance.
Okay, so open architecture is in our philosophy. As we interact with all our partners, starting from open code, open compute, APIs, network, standards, and the whole ecosystem. And today we have seen most of our partners who are with us now and here, whom we are working with them to build the whole open ecosystem at Jio.
So really, just to sum it all up, what does it mean to be open at the source, which for us is really what open source means? It really means that we have to follow certain principles of how to be open. And those principles, as we see it, are that you have to be the enabler for the free exchange of ideas. You have to be the enabler of giving every person, whether it is within Jio as employees, our partners with whom we have very strong collaborations, or every Indian through the digital lifestyle that we have enabled, we have to give them the freedom to learn and to grow. We have to allow people and enable people to collaborate. And these types of forums obviously make that happen. But again, using digital tools. And Jio has really adopted this at the core, the way we have created communities with our distribution partners, the way we have created communities with our own customers. But really the spirit of this is, how do we create ecosystems and how do we create a spirit of collaboration using digital technologies? We have to create the freedom to experiment. At all times within Jio, what we say is that, look, don't be afraid to fail. Try a few things, test it, feel confident, learn from your mistakes, and then improve. That is the spirit in which I think now we are starting to operate, and this really truly reflects the spirit of openness. Finally, I think you also saw this in the Reliance values slide, 100% transparency, and this is something that we absolutely insist on at Reliance and at Jio. We call it transactional transparency. There is nothing called my domain or your domain. We have to be open to commentary, we have to be open to constructive criticism, we have to be fully transparent in how we go about dealing with things. And this truly enables the best ideas to emerge. This truly allows people to improve your own ideas going forward. And finally, we will win or fail on the strength of our ideas, on the strength of our talent, on the strength of our accomplishments. This is what we call meritocracy. So these are the principles. And in my opinion, these are also the very same principles that underlie the open source software movement. But to generalize it a little bit more, I think these are the principles that have to guide us in every step of what we do. So in summary, we are Jio, we are open. This is our humble experience that we want to share with all of you. And hopefully this resonates with you. And once again, thank you all for coming here. And we hope to see you again in a similar forum in the future.
Thank you so much, Mr. Anisha. Thank you so much, Mr. Kiran Thomas. Well, yes, ladies and gentlemen, we'll now be giving away the prizes. In fact, we have one surprise prize also. But first, let's give away the prize for the best idea. We have already given one. The second one, we had the best ideator, Mr. Siddharth Rath. Do we have him here? All right, a huge round of applause as he wins iPhone 10. In fact, the top 2 ideas were selected and voted by you all. So congratulations, Siddharth. We also have one more prize, and that came as a surprise, indeed. So we had Mr. Kiran Thomas ask a question that what is the area that we actually began, Reliance Industries began, and the answer was spices. That was in 1958 that Shri Dhirubhai Ambani started Reliance Commercial Corporation, back then Masjid Bandar Road. So the answer is spices, and the winner is Jagdish Shawa. Could we have you on stage to receive Samsung, right? Do we have Samsung? Note 8, yes? All right. He's all smiles. That's truly come as a surprise for you, right? Go ahead, all yours. Congratulations. Thank you so much, Mr. Shah. Thank you so much, Mr. Thomas. All right, ladies and gentlemen, with that, we come to an end of the India Digital Open Summit. Thank you so much for being an active participant in every way and an amazing audience. I'd also like to thank Linux Foundation as well as Cisco Systems. And once again, thank you all. Please do join us for high tea. Have a lovely weekend ahead. Thank you so much.
Thank you, gentlemen, ladies. Thank you very much once again. This has been our first session, and believers, we will have more sessions to come next year. And please do not leave unless you do the networking, because that's why we're all here. And thank you once again to Cisco. Thank you once again to Phil, Rob, and the Linux Foundation and team. Thank you very much. Thank you, folks.